is Abel, and I'm a principal, cloud advocate, and the DevOps lead at Microsoft. And I'm super excited to be here presenting on getting started with DevOps session. Now, this is the first of 5 sessions in the DevOps learning path, where we give you an in-depth look at the how, why, and what it means to run a successful DevOps strategy in your organization. So in this session, we'll be looking at getting started with DevOps. For this entire series, we will be outlining issues that need to be solved within a company called Tailwind Traders. And just what is going on with Tailwind Traders? They've been growing rapidly, and senior team members have recognized that differing goals across teams has caused a rift in communication and collaboration. So they've started an initiative to implement a DevOps strategy to help with collaborating across their growing teams. So the first thing they'll look at is things like source control, better collaboration tools, and shared tooling in general. And today, we'll discuss how each of these will enable their teams to be successful and grow right alongside their application and customer base. In this session, we'll be covering things like what is DevOps and why is it a good fit for Tailwind Traders. We'll talk about source control with an introduction to Git and GitHub. And we'll take a look at how Tailwind Traders can use Microsoft Teams as their collaboration hub. And we'll talk about how they can extend their DevOps experiences by using Visual Studio Code. Now, before we get into tooling, what exactly is DevOps, right? Because if you ask 10 different people, guess what? You're probably going to get 20 different responses. At Microsoft, DevOps is something very specific to us. So at Microsoft, DevOps is the union of people, process, and products to enable the continuous delivery of value to your end users. Now, I said this very carefully because every word of this definition has meaning. Now notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on a source control server somewhere. Who cares, right? That does nobody any good. And notice I didn't even say continuously deliver features, because again, we could be delivering feature after feature, sprint after sprint. But if it's not what our end users need or want, we're just wasting time. So the key here is we have to continuously deliver value and doing whatever it takes to be able to do this. But why, right? Why is this so important? Well, the speed of business today is so ridiculously fast that the only way dev teams can keep up and innovate fast enough is if they adopt DevOps best practices. And the sad truth is, if you don't adopt DevOps best practices, your competitors, they either have or they will. And once they do, they will out-innovate you. And when that happens, you become obsolete. And none of us wants that to happen. So this used to be DevOps theory, but we've been doing this long enough now that we have empirical evidence that shows teams that adopt DevOps best practices absolutely out-innovates teams that don't. But it's not easy to do right. To do DevOps correctly, you must address all 3 pillars, right? The people, the process, and the products that help enable everything. Now, the people pillar, that's a cultural shift that needs to occur where everyone from the very top of your organization all the way to the bottom, everybody is hyper-focused on continuously delivering value, no matter what it takes, where any and all walls and areas of frictions, they're knocked down to allow continuous delivery of value. And we need processes in place that will let you innovate fast enough, yet still deliver code of high enough quality, where you have frequent iterations so quick course corrections are possible, where you have automations in place to speed up this process and to reduce human error, where even when your app reaches production, it doesn't end there, because you still need to monitor your app. You still need to know, is my app up or down? Is my app performing well? And what are users really doing in my app? Because those things can help me identify, am I delivering value, sprint after sprint after sprint? And based off of that, we can course correct in our next iteration if we need to. And guess what? Agile processes, they work perfectly here. And finally, we need products, right? Tools that help enable all of this. And one of the most fundamental and important tools is source control. Now, source control is a form of version control. It uses the concept of code repositories to track changes on all artifacts within the repository. It enables cross-team collaboration through things like branches, versioning, commit history, and code reviews. One extremely popular and useful source control protocol is called Git. A Git repository, at its core, is a collection of files and folders that comprise a product or application. Some common things you'll find in a Git repository are things like the actual source code for the project, a .gitignore file that allows you to tell Git to ignore certain files you're not tracking, and branches that allow you to isolate development from work from your main or production code. So this allowed developers to work on things in an isolated area without affecting a live code base. And changes within those branches can later be merged back into the main branch as work gets completed and reviewed by your team. Now commits that track changes to the artifacts within the repository so that now you can better understand what changed, when it changed, who changed it, and why it was changed. And tags, which point to a specific release of your code base. Now, the true beauty of source control is the ability for an entire team to work on that same code base without stepping on each other's toes through the use of branching, merging, and versioning. Now, the most well-known and the leader in Git repository hosting is GitHub. Now, some of the features that make GitHub so awesome include the ability to track things like issues, bugs, and features across your project. Also, the ability to more easily share and collaborate expertise by encouraging comments and communications at various steps of code writing. And the ability to easily set up a whole bunch of integrations with other services like Microsoft Azure. And you even have the ability to do work inside a hosted instant, fully featured dev environment through code spaces on GitHub without ever having to leave your browser. Now, one of the most powerful features inside of GitHub is GitHub Actions. This allows teams like Tailwind Traders to automate their software workflows with world-class continuous integration. So what this means for Tailwind Traders is they won't have to worry about manually kicking off builds, testing, and deploying to validate their products are ready to be deployed. So with a little setup, GitHub Actions can handle that and make sure their product is all bundled up and ready to deploy as developers submit pull requests, also known as code reviews, to their projects. And all of this means the developers at Tailwind Traders have a more streamlined process for delivery of their applications. So less time spent on mundane tasks and more time spent on doing what they do best, which is writing code for their projects. So what are some of the things you'll find in a GitHub project that you won't find in a standard Git repo? Well, first, you have a README Markdown file that allow teams to better document the project within their repository. Also, a security Markdown file that allow teams to define their security policy. A license file that defines the license for this project, and code owners file that allow teams to define who is responsible for what parts of the code base. Pull requests also are super cool because that allows you to request to merge a set of changes that exist in one branch into another branch. And this feature also allows teams to double check work and communicate changes before they're merged into the code base. So issues is another thing, right? Issues allow you to track things like bugs, features, or general requests within your code base. And bundles of specific iterations of your projects, those are referred to as releases. So let's take a quick look at GitHub in action. So as you can see, Tailwind Traders, they've uploaded their website as a project on github.com. And this project is called Tailwind Traders-website. So this is the main branch, and this is the source code that exists inside the main branch. If we click on the main button over here, we'll see I have a whole bunch of branches, and we also have a license file. And we can see that we are using the MIT license. we also have a readme.markdown file, and this file gets rendered down below and shows information about this repository. So things like requirements, prerequisites, ways to deploy the project, specific information about this project that I think collaborators need to know. So this is a very important step in creating your project in GitHub. Now across the top we have tabs like this pull request that shows all the open pull requests, which are requests to merge changes from one branch to another. And this is where our team can collaborate and review changes together before they get merged into our main code base. All right, let's go ahead and check out the Actions tab. And this is where you would go to set up or manage your action workflows. So things like CI/CD, which is continuous integration and continuous delivery. We also have the Security tab, and this shows things like your security policy and advisories. Now, if you don't have a policy, you can set it up here by clicking Start Setup. So you click this button, and this will pre-populate with a sample security policy.markdown file. We can click on the Preview button, and now we can see how the markdown will be rendered, and we can see our policy shows supported and unsupported versions, and it also shows how to report a vulnerability. And if I wanted to, I can commit this file right to the main branch, or I could use DevOps best practices and create a new branch for this commit and start a pull request. And I can do all of this right here from within my browser. All right, let's take a look at the insights. And here you can show different analytics about your projects, information about your community, traffic, commits, how many pull requests you've had, things like that, right? And in the settings, this gives you access to things like managing access. So you can see I've added Able to this project here. And you can set up security and analysis features as well. And you can change your default branch name if you want to. You can set up protection rules where you can disable force pushing and branches from being deleted. You can also set up webhooks, which allow external services to be notified when certain events happen. And you can see I've set up 2 webhooks already for notifications within our team. And under the Notifications tab, you can set up who will actually get notified, right? You can either put in emails or an entire list. You can also set up different integrations, deploy keys, actions and permissions, moderations. Ooh, check out the moderations. This is kind of neat. This is where you can restrict users from interacting with your repository for a 24-hour period. All right. Let's go back to pull requests, and we'll check out a pull request that Abel did. So here, he added a security.markdown file to the project, and he created this pull request to get permission to merge his changes from his personal branch into the main branch. Now, when we go into the Conversations tab, you can see that there has been one commit that added the security.markdown file. And this is where continuous integration and testing would have run with GitHub Actions if it had been set up. You can also see this branch has no conflicts with the base branch, which means if we click that merge button, it will just merge cleanly into the main branch. Now, if we go to the Commits tab, we can see one file was added, and if I click on File Change, I can literally see everything that was changed. And I can also click here to leave an inline comment. And when I add this inline comment, it's going to create for me a review request. Now, if we go to the Conversations tab, we can see this review request in detail. And you'll see this yellow box, right? This shows this is in review, and I've started a conversation. So now here is where the rest of the team can weigh in with comments and suggestions before they allow this merge to go through. Or someone can come in and approve this, which would allow the merge to happen. All right, let's look at a pull request that I created myself. And as you can see, we can drill into the commits, and I can see I created a file, and I can go to the File Changes tab, and here I can leave a comment for myself, and I can still start a review process even though I created the comment. Now, if we go into the Conversations tab, you'll notice that I can still see the review section. I can still leave comments, but I am no longer able to approve my own requests. And this reinforces best practice around having your team peer review every change before merging. All right, let's look at adding and removing code. If we click on the Add File button, here we can create a brand new file or upload new file all directly from the browser. And if we click on this code, this is where we can create a repo locally, right? So let's go ahead and do that. If I type git clone with that URL, it's going to pull down my remote repository and stick it on my machine. And I can cd into this directory, and that will take me to my repository on my machine. Now, following best practices, you never want to make changes to your main or production branch. So let's go ahead and create a brand new branch. I'm going to add a collab.txt file. So let's call this branch collab-file. And I'll do this from the browser. And we just created a brand new branch, right? So now let's pull this branch down locally. So I'll issue the command git pull. And this will pull that branch down. And to use this branch, we can check it out by saying git checkout collab-file. And now we're in the collab file branch. Now it's based off of the main branch, so you're still going to see the same files. But now when we do work, we're in that isolated branch. So we're going to create that collab.txt file. And once I do that, let's do a git status. And you'll see that we have a new file, but it's not being tracked. And that's because collab.txt didn't exist previously. So we need to add it, right? Let's issue the command git add collab.txt. And this will tell Git to start tracking this specific file. And now when we do a git status, we'll see that there is a change. We added the file and it's ready for a commit. So we'll go ahead and do a commit, which is git commit-m with a short message that tells us what this commit was for. And once that's done, we'll do a git.push, and this will push those changes back into the browser, or not browser, back into GitHub. So we'll jump back to the browser to take a look at what that looks like. So it says, guess what? Collab file, it had one recent push less than a minute ago. If I refresh this browser, we'll be able to see the collab.txt file, and bam, there it is. So that's awesome. So the next step is to get my changes into the main branch, right? So which means I have to create a pull request. So I'm going to go ahead and leave a comment here. Let's say adding a collab.txt file. And you can see it's going from the collab file branch to the main branch. And I can go ahead and create that pull request. And now we open up the conversation and it's checking for the ability to merge my changes automatically. And under the file changes, I can enter a comment to start a review of this pull request. And now that I've started that review, I can start a conversation, right? And here, my team can now jump in, review my code, and give me suggestions. Or if everything looks good, they can go ahead, approve my changes to be merged into the main branch. So right there, that's a quick run through of GitHub and how to use GitHub for both source control and for your pull requests. So Tailwind traders, they have GitHub projects for their applications, and they're on the right track now. But there are other things they'll need to keep track of as well. Things like communications with the team, calendars, conference calls, meetings, files that they use. So how can teams like Tailwind traders more easily collaborate across their organizations? So this is where Microsoft Teams comes in. Microsoft Teams is the hub for teamwork. Some key features that make Microsoft Teams so great are the ability to chat, meet, call, and collaborate from anywhere. And with a full Microsoft 365 integration, you can easily schedule meetings, check out your calendar, and join conference calls directly within Microsoft Teams. And if you need to chat with your teammates, you have instant messaging built in across your organization as well. Microsoft Teams can also be extended with countless integrations for other applications and services. And by using Microsoft Teams, Tailwind traders is able to simplify and effectively amplify collaboration across their entire organization with minimal effort. And speaking of integrations, Microsoft Teams has an integration for GitHub via the GitHub for Teams app. It allows you to subscribe to projects within GitHub to get updates on issues, inspect commits, collaborate on pull requests, and much, much more, and all without ever having to leave Microsoft Teams. You can also add a tab at the top of a channel so the entire team can more easily track things like pull requests. And this integration allows teams like Tailwind traders to more easily collaborate on changes within their code base without having to jump back and forth between different applications. Another awesome integration within Microsoft Teams and GitHub is the GitHub Enterprise app, because this allows you to set up a connector that sends notifications directly into a specific Microsoft Teams channel about updates and changes that happen inside of your GitHub project. You'll be able to track changes live in a channel and watch and interact with things like commits and pull requests. And what the connector sends into the channel is, of course, completely customizable through a webhook in your GitHub project. So let's take a quick look at Microsoft Teams in action. As you can see, Tailwind traders, they've started to configure Microsoft Teams as their collaboration hub. So first they created a Tailwind traders team, and you can see if I go to manage this team, they have lots of members and guests that are invited, and I can see their roles, I can change their roles, I can set tags, locations, things like that. And under the teams, we have a general channel for general chatting. We have an Azure Board web channel for Azure Boards activity. And we also have a GitHub web channel for GitHub activity. Now let's take a look at the general channel, and you can see notifications are already happening from the integrations that I've added. If we go to the Files tab, these are the files we have in our SharePoint. And if I click on this file, it will open up this file where I can start editing it right here inside of Teams. And if I want to, I can open it on the desktop, or if I want to view this in SharePoint, I can simply click on Open in SharePoint, and it will take me directly to my SharePoint site. We've also integrated with OneNote, so here's my OneNote notebook. And under here, you can see we're capturing meeting notes right now. We've also set up a SharePoint tab, and this will show us any files we create inside the SharePoint for our team. But what about meetings and conference calls? Well, let's take a look. So you can see here that we have a fully integrated calendar, and all my information is right here in Teams. And if I needed to join one of these meetings, I can simply right-click on it and join without needing to leave the Teams experience. And what about calls? Yeah, I can do that as well. I can accept calls, I can make calls, and I also have integration to a whole bunch of third-party applications, things like OneNote and SharePoint and also GitHub. And speaking of GitHub, I've configured GitHub to send me updates from our GitHub projects in real time into our chat. So this helps me keep an eye on things that I care about. We also have this GitHub tab, right? And this will show us all of our live and open pull requests. So those are open and closed for our project. I also wanted live updates to happen in our chat channel, so I used the GitHub Enterprise connector to send these live updates from our project right here into our GitHub web channel. Now, we didn't want to flood the general chat with this type of activity, so that's why we created this separate channel. I've also created an Azure Boards web channel, and we set it up very, very similar to how we set up this GitHub web channel. So this channel is showing us updates inside of our Azure Boards, where we can keep track of things that's going on, right? So this is our Azure Boards, and we're doing all sorts of stuff, right? We're tracking all of our work items for our project, and as work is being done, right, as it's being moved, as work changes, as things get assigned, all these changes are actually reflected right here in the Azure Boards web channel in the chat in real time. And this makes it really easy to see what's going on without having to leave the Microsoft Teams experience. Now, we've also configured the Azure DevOps app to show our board right here inside of Teams. And what's even better, you can do real work here. You can move items, assign things, make updates, all right here without having to leave Teams. And just like before, you can see these things happening in real time in the Azure Boards web channel. All right, I noticed a moment ago that Abel had moved one of these tasks to the done column because he completed it, right? So here we go, there it is. So that tells me there's probably a pull request that's open. So let's go check. We'll pop on over to our GitHub web channel and we'll look at the pull request tab. And as you can see, 5 hours ago, Abel opened up a pull request because he added that security.markdown file and he wanted the team to review it. So here I've started the review process for this pull request, telling the team, hey, let's go ahead and review it. And it looks like he's adding that sample.security.markdown file. And that's totally fine for us because, we're just starting out with this file. So I'm going to go ahead and add a comment and write him a comment telling him, hey, everything looks great. And I'm going to go ahead and merge this. So I'm going to set it to approve and submit my review. And now that that is all done, you can see there is one approval, and I'm going to go ahead and merge this pull request. And after clicking merge pull request, you see there's a note here about the merge that's about to happen, and I'll go ahead and confirm it. And you'll see that the pull request was successfully merged into the main branch. Now, if we go back into Teams, the web channel, you'll see all the updates have happened in real time, and it's been reported right here inside the channel. And this freaking rocks, right? Because the beauty of this is the rest of the team, they didn't have to be inside of GitHub. Now they can see these notifications as they're doing their daily work, and these notifications happen right inside of Microsoft Teams. Now that we've taken a look at GitHub and Microsoft Teams, we're going to take a look at Visual Studio Code and how that can help Tailwind traders. Visual Studio Code is an open source free text editor. The source code, it's on GitHub, and you can download and run this app on Windows, Linux, and Mac. And it has Git commands built right into it. It also has language support for all kinds of languages through extensions. Now, these extensions, they can be found in Visual Studio Code Marketplace, where there are literally thousands of extensions. Extensions for all kinds of languages, extensions for tooling support, extensions for connectivity and deployment, and extensions that support multiple cloud, not just Azure. So here's an example of a cool extension. This extension is for the Azure CLI, and you can create a script with the Azure CLI which lets you use the command line to do just about anything inside of Azure. Now you can save this file as a bash file, as a shell script, as a PowerShell script, or as a .az CLI file. Now if you save it as a .az CLI file, that's when the magic happens, right? Because you get IntelliSense and code snippets that you can use inside of your code. It also has integrated terminal, and you can create a side-by-side editor to make sure your CLI script is doing what it's supposed to do. And you can get documentation on mouseovers as well. Here's another cool example. This is the GitHub pull request and issues. Now, Git capabilities for push, pull, and other basic Git commands are built right into VS Code, the core product. However, GitHub-specific things like tracking issues and pull requests, those are not. But you can download this pull request extension, and now you can do things like review and comment on pull requests, and validate pull requests, and check out users. And these are all built. There are also some built-in actions to start a branch or create issues from to-do comments, right? So a really powerful extension. There's also a live share extension pack that's super, super cool. This lets you code and collaborate in real time with anyone else that has VS Code. They need VS Code and the live share extension pack. And you can do all this live coding with both video and chat. So enough of flipping around through slides. Let's see all these cool things in action. So now Brian Benz is going to come. He's going to jump in and show us the power of Visual Studio Code.
So here's Visual Studio Code, and I'm working on a site called Tailwind Traders website. This is a local clone of something that I have on GitHub. And basically the code is here on the left. There's something I'm editing on the right, in this case a YAML file. And here's the GitHub capabilities that we have built into it, which I'll be demoing a little bit. The extensions that I mentioned before are here. So these are the extensions I have enabled, and then they make recommendations on other extensions. There's also the GitHub pull requests extension that I mentioned. And here's, for example, pull request created by me, and it's got all kinds of information in here about the pull request. This is actually me doing a reverse pull to bring in the latest version of Tailwind Traders from the main site. So let's have a look at that on GitHub and see what it looks like. So here's the Tailwind Traders website on GitHub. And as you can see, it's forked from Microsoft Tailwind Traders website. I've got several commits that I've done, and you can see over here on the right, it's 40% JavaScript, 31% CSS. It's got some C#, some PowerShell, some HTML. It's got a shell script in there and some other, which is Node.js and a couple other things. So basically what I'm going to do is I'm actually going to edit some actions that we have created, and we're going to push this to a website that we've already set up. So I'm actually going to go down here. If I look at my code, I want to change this. Instead of saying deploy to website, I want to call it deploy to staging website, because we're actually deploying to a staging site up here. Deploy. It's called Bben's Tailwind Staging. So let's save that. And if you'll see over here on the left, it tells me if I go into my built-in GitHub capabilities here, I've got one change, which is main YAML, and that needs to be committed. So let's say I change that, change deployment to staging. All right, I saved that. If I click the little checkbox here, it's going to tell me it automatically commits it, but I forgot to stage it. So this is one of the nice things about Visual Studio Code. It reminds me, hey, you have nothing staged to commit. Do you want to stage your changes and commit them? Yes. So it will actually commit them. Now I have different options for actually getting this out to the GitHub repo. Remember, this is my local clone. So I can just push, or I can do a sync. I really like doing the sync because it pushes and pulls any commits. So if this is being worked on collaboratively, I make sure that I have the most recent versions from the upstream. Okay, so now the change is gone and it's been committed. So what happens, this is a GitHub action, and it's a GitHub action on push. So what's going to happen is when you actually push out to the repo, an action will be triggered. So let's check out that action. The action's actually working. So let's watch that run. And let's actually go into the build and have a look at that. So right now it's installing dependencies, and then it's going to build. So let's just wait for that build and make sure it succeeds. Looks like the build went through, the test went through, and now we're going to publish. So in a few seconds, this should actually publish out to the website once we get down to the deployment stage. Oh no, looks like it's failed at the publish stage. Unfortunately, I'm not sure why. Let's scroll through here and see if we can find out exactly what the error message is. One of the things that is possible at this point is that this is a GitHub Actions environment. It's a very standardized environment that GitHub Actions uses, but maybe there's some special things set up in our development environment that this would run. So for example, this might work on a developer's machine, but for some reason it doesn't work in the GitHub Actions generic environment. So there is one thing we can do to test that out. And it looks like in this case, it's not a problem with NPM, but there is a error on Node SAS, which looks like a dependency on Node. So I know it's something to do with Node. But before I go too far into debugging this, why don't I try running it on a customized environment and see if that works. So to do that, I can actually use something else that's inside of GitHub. If I go straight into my Tailwind Traders main site, I can open with code spaces. So code spaces for GitHub is a way to create a standardized environment that you can reuse. So let's create a new code space, And what that's going to do is create a space based on the parameters that my organization has set up inside of here. And there might be something special in here that runs that wouldn't run in the generic environment and allows me to publish and deploy this. So it takes a few seconds to start the code space. But once that's done, it's going to build a container and it's going to run the container, and then I'm going to have everything in my environment here just the way it looked in Visual Studio Code. Now here we are. It's just opening the code. So basically, if you look over on the right, it initializes a code space, builds a container, runs the container, and then it configures the code space for you. So it basically does a clone into this environment. And it creates this container in a environment that can be reused later. So now we can check out this code, and we can see here, for example, we have issues with Tailwind Traders Web, and let's go in and see what that is. So yeah, looks like the object release, something to do with the attributes here. Yeah, it's very odd. So this isn't going to work even in this environment. Unfortunately, it's not going to work. There's just something wrong with the build and the way it publishes. It's very strange that it worked when you did the build, but not the publish. So let's check out another way we can do this. And by the way, I'm showing you this from GitHub, so CodeSpace is on GitHub from the web. There is another way to access that, and that is through the remote extensions. If you go to Visual Studio Code over here, there is a way to connect to CodeSpaces here, and that'll be the CodeSpaces on GitHub, but you'll be opening it in a new version of Visual Studio Code. It'll look at pretty much the same as it did in that environment that I just showed you. All right, so the next thing we want to do is we want to figure out, I'm at the end of determining, end of my skills and abilities at determining what is exactly wrong with this build. So what I'm going to do is I'm going to connect with a colleague and see if he can help me. This code obviously has some issues. I'm going to need some help figuring out exactly what those issues are. So because I installed the LiveShare extension pack that I mentioned earlier in the slides, I can actually start a live collaboration session, and it's copied to my clipboard now. So what I'm going to do is I'm actually going to phone a friend. I'm going to phone my colleague, Zach, and Zach's going to hop on the line and help me figure this out. So let's do that now. Calling Zach.
Hey Brian, what's up?
Hey Zach, how you doing? You got a few minutes?
Sure. What's going on?
Okay, cool. I've got an issue with some code. I can't quite figure out exactly what it is, and I could really use your expertise. So I'm sending you a LiveShare link. You should see it in the Teams chat now.
Yes. Okay. Let me join that.
Okay, cool. Great. I'm going to take you off this screen. All right. So let's have a look at the code now. So Zach has joined the collaborative session. So great. So here's the code, basically. It's a GitHub action, and it seems to be failing on Node. I'm not sure exactly why, but I was hoping you could help me out there.
Yeah, so it looks like you have your Node version set to 14, and it might build in that environment, but I think your target environment requires an older version. So let's try Node 10.
Okay.
And see how that goes. I'll save this for you.
Beautiful. Thank you, sir. All right. So if we go back into our GitHub controls here, you'll see that there is one change, and it's already populated a comment here, which is co-authored by Zach. So change to Node 10. All right. So what I'll do is I'll commit, and I forgot to stage. So one of the nice things about Visual Studio Code is it reminds you, hey, you don't have anything staged. So yeah, I do want to stage that. And then I could just do a push, but I always find it safer to do a sync. So sync does a push and a pull using the built-in Visual Studio Code commands. And that goes out there. You'll see when this blue finishes that it's actually pushed to the repo. One thing before we leave Visual Studio Code, I did want to mention inside of LiveShare, I could do an audio call as well if I have multiple people and maybe they don't have Teams set up. But for now, I just kept it simple, and Zach and I are talking on Teams instead of joining the chat here. So good to use the tools no matter what you have. There is a way to share the audio. So let's go over to the GitHub action now. If we go in here to the website, if I check actions, as expected, I see that it's running as co-authored by Zach, and the build is in progress, and should just take a couple of seconds to go here. All right, looks like publish happened. That is farther than we got before, so this is great. So let's just check out and make sure it publishes to the website. Well, looks like we published to the website. Let's go back in there and let's check this out. So it should be this URL. Should be able to open it. Let's go in a new tab. It looks like the website's loaded. Fantastic. So we solved that problem in a second. That's what collaboration is all about. Thanks very much, Zach, for your help in that live collaboration session.
No problem, Brian. Have a great day.
All right, you too. Thanks.
Thanks, Brian. Man, that was a very cool demo showing the power of Visual Studio Code, code spaces in GitHub, and also LiveShare. Okay, so we've covered a lot in this session, so let's do a quick recap. At a high level, we covered how laying a solid foundation for a DevOps strategy can help solve the issues that Tailwind Traders has been facing. And now that Tailwind Traders has a story for source control, collaboration, and shared tooling, they are on the right track to continue down the path of a full DevOps solution. So we also talked about what is DevOps, what is source control, with a quick intro to Git and also GitHub. We discussed how Microsoft Teams has enabled more effective collaboration across the Tailwind Traders organization. And we looked at how Visual Studio Code can help solve problems with shared tooling and even more collaboration. So if you'd like to take a deeper look into what DevOps is with overviews, tutorials, samples, and more, head over to aka.ms, all things DevOps, where you'll find our DevOps Resource Center. And if you'd like to explore the collection of Microsoft Learn content for the AZ400 Designing and Implementing Microsoft DevOps Solution certification, head on over to aka.ms Getting Started DevOps. If you'd like to learn more about getting certified, you can head on over to aka.ms/AZ400cert. So, thank you all so much for joining us, and join our next session too, Managing the Flow of Work. In this session, we'll be covering how Tailwind Traders manages their flow of work. Tailwind Traders, they've gone all in on DevOps. They've read about it, they've studied it, they've gone to classes on DevOps. They 100% believe this is the way going forward. And in the last session, Getting Started with DevOps, Tailwind Traders, they've even decided on their tooling stack. So now they're ready to start DevOpsing. But what exactly is DevOps? You ask 10 different people, you're going to get 20 different responses. At Tailwind Traders, they decided to adopt Microsoft's definition of DevOps. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. Now notice, I said this very carefully because every word has meaning. Now notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on some server somewhere. This does no one any good. And notice, I didn't even say continuously deliver features, because I could be delivering feature after feature, sprint after sprint. But if this is not what my end users need or want, why am I wasting my time doing it? So the key here is we need to continuously deliver value. It is 100% vital that Tailwind Traders continuously delivers value. But why is this so important? Here's the thing. If you haven't adopted DevOps best practices, your competition, they either have or they will. And when they do, they will out-innovate you. And when that happens, it's game over. You will quickly become obsolete. And none of us wants to be obsolete. Now, this isn't just DevOps theory. We've been doing this long enough now that we have empirical proof. Organizations that adopt DevOps best practices absolutely out-innovate teams that don't. And not just by a little bit, but by a lot. And this is why Tailwind Traders needs to adopt DevOps best practices. But it's not easy to do right. In order to really adopt DevOps best practices, you have to address all three of these pillars: the people, the process, and the products. Now, people, that's a cultural change that has to occur within your organization, where every person from the very, very top all the way down to the bottom must be hyper-focused and aligned on continuously delivering value. For the process, we need a process that will let us iterate fast enough, yet still deliver code of high enough quality. Now, finally, we need products that can help enable all of this. And at Tailwind Traders, they've got the people and the culture down, right? Everyone has been trained. Everyone is aligned and believes in DevOps. Everyone is prepared to do whatever it takes to continuously deliver value. They've even got their products and tools down, as you saw in the first session. So all they need to do is just figure out their process. Now, in order to continuously deliver value, they need a process that is highly iterative, yet still delivers code of high enough quality. And it needs to be highly iterative because they want to have many frequent small releases versus infrequent large releases. This way, they can continuously deliver value. Now, with many small iterations, they also have the ability to course correct really quickly. Now, we don't always know if what we're doing is what the end users really wants or needs. So if we have a lot of small iterations, we can now make a hypothesis, spend, let's say, 2 weeks implementing it, release it to the public, gather telemetry to see if end users really value this new feature. And if they do, hooray for that. We can double down on features like this or even expand upon this feature. And if they don't, not a big deal, because we've only wasted 2 weeks versus months and months and months of dev time. We will just reprioritize the backlog and then rinse and repeat this process. So what kind of a process will let us do this? Agile and the many flavors of Agile. So things like Scrum, Kanban, Agile with a capital A. Now, personally, I'm a massive fan of Scrum. I love Scrum. I'm a Scrum purist, and I've led several successful dev teams using the Scrum methodology. And I'm not saying any of the other flavors of Agile aren't good, because they're all good, they work. But today, we're going to be looking at Scrum. In Scrum, everything starts with your backlog. And what's a backlog? Think of it as a prioritized wish list of everything you want your software to do. So the most important things are at the top, and the least important things sink to the bottom. Now, at the beginning of a sprint or an iteration, the product owner will go ahead and prioritize that backlog. And then the team will commit to doing part of that backlog based on the priority and what they think they can get done. And then they'll spend the sprint working, they'll burn down whatever bugs are found in sprint, and at the end of the sprint, they'll show what they've accomplished to the product owner in a sprint review meeting, and hopefully they'll push into production as well. And based on the sprint review demo, the product owner then will reprioritize that backlog, and this whole cycle can rinse and repeat itself. So that was a super quick description of Scrum. So let's dive in a little bit deeper and look at some general principles. First of all, this is not a waterfall project. We don't build the entire thing and then release it. We build it up incrementally, so sprint after sprint, building the highest priority items on the backlog first. And we do this because this allows the product owner to look at what we're building at the end of every sprint. And when they do, they can now give immediate feedback. So this here is vital. Most of the time, people don't really know what they want their software to do until they start clicking on the buttons. Because you notice how people are super quick to tell us what they didn't like versus what they want their software to do. So by building our software incrementally, we can now have frequent inspections of our software and immediately course correct as needed. So instead of wasting months of work, the worst that could happen is we waste one iteration and then we course correct. So super powerful, super useful. All right, next in Agile or Scrum, everything should be transparent. The dev team, they're not working in a vacuum. The product and sprint backlogs should be public, where everyone can easily see what the team is currently working on and what the team will most likely work on next. Transparency and communication, again, is another key part in Agile and in a DevOps world. Next, I wanted to touch on what makes up a Scrum team, because there's only 3 roles. First, there's the product owner. There's literally one job for the product owner to do, and that is to prioritize the backlog. The first thing I tell a new product owner is that this is not a waterfall project. Again, we don't ship when everything is finished. In fact, most likely, we won't ever get to a point where everything on the backlog is finished. So hopefully we'll be shipping at the end of every sprint. So we need to make sure that the most important features are prioritized so they get done first. Prioritization and then the course correction that comes from reprioritizations, that right there, again, another key concept inside of Scrum. Now, in order to be able to prioritize correctly, the product owner has to be able to make decisions on how that product will function and what it will look like. Or said another way, the product owner has to have a vested interest in the end result of this piece of software. The success or failure of this piece of software must directly affect the product owner. Next, there's the Scrum Master. Now, the Scrum Master has 2 roles. First is to make sure the team follows Scrum best practices. And second is to protect the team, the Scrum team, from outside interference. You ever get that high-level exec that walks up to a dev directly and tells them, I need you to add this feature immediately, right? And of course, this messes up everything from the planning to the scheduling, so on and so forth. It's the job of the Scrum Master to protect their team from people like the high-level exec. They need to be able to tell them, nope, you don't get to do that. You can't drop something on us mid-sprint. Put it on the backlog, you can rank it really high, and we can tackle it next sprint. Finally, there's a dev team. This team, it needs to be cross-functional. When there's someone on your team, you need to have people on your team that can do whatever, whenever that needs to be done for the project. And the more cross-functional your team is, the better it is. Now, I know in an ideal world, every person on the team can pick up any work on the backlog and just get it done. In reality, most people are not 100% full stack, right? But you just need to make sure there are team members that can cover tasks, the different types of tasks. However, we do strive to be cross-functional. So sure, we do each have our own areas of specialty, but don't let that stop us from grabbing tasks, learning, and growing. Let me give you an example. I was once on a project where I finished up all my tasks, and I'm a back-end dev. The only remaining work in the backlog was some crazy SQL query. Now, I do know SQL, but I'm really kind of good enough at it to be really dangerous, right? That's the level that I'm at. So yes, I did pick up that task, but I also pinged my teammate, who is an expert at SQL, and I asked them to pair with me. Because now they can make sure I'm not doing anything crazy or wrong, and I can also learn from them. This will help me ramp me up. It will upskill me on my SQL skills. All right. Finally, these Scrum teams, they should be self-organizing. No one needs to direct a Scrum team on how to do the work, what they need to do, so on and so forth. They can figure that type of stuff out for themselves. All right, writing software, it is like a 3-legged stool. You can have quality, you can have a date you are done, and you can have features. And guess what? You can only move 2 of those things, right? And in a software project, quality is not negotiable. You cannot skimp on quality. So what that means is if you want more features, you must move the delivery date out. And if you can't move the delivery date, you're going to have to reprioritize the features that you're going to ship with. It is that simple, and there are no exceptions to this. Also, when you're planning, estimates, they're not guarantees. And although the more you do it, the better you do get at it. So estimates, they've always been a bit fuzzy, but to help with your estimates, here are my rules. I want to break down all of my work into 4-hour chunks. Why 4 hours? First of all, it's a lot more accurate. I'm pretty good at estimating things within 4 hours. I'm pretty good at estimating even a day's worth of work. 2 days of work? Yeah. More than 2? All right, more than 2, I'm starting to guess. Now, my go-to estimate, if you ask me how long it will take to do something, I'm always going to say 2 weeks. Why 2 weeks? Because I think I can write just about anything in 2 weeks. I can probably write an entire OS in 2 weeks. But to be really accurate, I'm only good to about a day or two. And I've been doing this for over 20 years. All right, so next, if we break down a user story into 4-hour chunks, there's now a possibility that instead of just one person spending 3 days working on this, this can be split up into a lot of small tasks, and my team can work on it in parallel, which means we can potentially knock this user story out much faster. Also, with much finer grained tasks, it is so much easier to track progress. So if I just have a task that's 2 weeks long, when I look at my board, how do I know work is progressing, right? Because we've all done this, where on day 1, we can say, hey, we're 20% done. And after day 2, we can say, hey, now we're 60% done. And then on day 3, we're at 90% done. And for the rest of the 2 weeks, it just stays at 90% done. And at the end of the sprint, we're still not done. So if you break down your tasks into 4-hour chunks, this lets us plan and track work so much better. And finally, never start from a date, right? Because developers, we're pleasers. We want to make people happy. So if you start from a date, we're going to magically subdivide the work up so they'll fit in the allotted time. Even though this doesn't work and it's not accurate, it's kind of what we do. So don't start from a date. Work out the task, break it down into 4-hour chunks, and then see where the end date lands. Finally, the rules apply to everyone. In order for Agile to work, everyone in the organization must be hyper-focused and aligned. So remember, the whole point of us moving away from Waterfall to Agile is we finally admitted that Waterfall does not work well for software projects. In fact, 90% of Waterfall software projects flat out fail. And by fail, I mean they go over budget, over time, too many bugs, or the end result is not what the end users want. So we know the old metrics and the way of doing things is garbage. We must all be aligned now with how things are done and measured in an Agile world. Everyone, from the very, very top all the way down to the bottom. And no one is exempt from the rules, no matter what their title is. Okay, so Tailwind traders, they get Agile. They get Scrum. But to do Scrum right, they need tools that will help them track their work from sprint to sprint to sprint. They need to be able to easily reprioritize work on the backlog, as well as track their work both within a sprint and across sprints. And all of this needs to be easily accessible by everyone, because remember, no one is working in a vacuum, right? The product backlog, the sprint backlog, the current product plan, those need to be publicly available. And guess what? Azure Boards, linked to my GitHub repo, does a great job of this. So let's check this out. In the world of Agile or Scrum, everything starts from the backlog. So here's my backlog, and as you can see, it's an ordered list of everything that I want my software to do. Adding new work, I can just click the new work button, I can give it a title, add to the top, and there it is. Now if I click on this particular work item, it opens up a form and I can give more details. So I can give things like descriptions, acceptance criteria, etc., etc. Now, if I want to prioritize my backlog, that's as simple as just dragging and dropping on this board. Now, the other thing people use the backlog for is they choose the work from the backlog and say, this is what I want to do for a particular sprint. So they create a sprint backlog. In creating, that's easy enough. I can just go ahead and multi-select, and then I can just drag it and drop it to the sprint that I want. And if I click on the sprint, it will take me to my sprint backlog. Now my sprint backlog behaves exactly the way I expect it should. You can now prioritize work by dragging and dropping. I can add new work as well. And the other thing it can do is I can break down my work into the individual tasks that I need to complete this item. So again, tasks, remember, they should be 4-hour chunks, right? So for this particular work item, let's say I need to update my database schema over here. And I also, let's break this down a little bit more. Let's say I need to update my API layer. Awesome. So pretty cool, right? Now I have my work item. I've broken it down into 2 individual tasks. I love backlogs, both the product backlog and the sprint backlog. They're great at adding and prioritizing work and doing breakdowns. But where they start falling down is tracking work as it's happening. Now, I want to be able to track my work as it happens, and I want to be able to do this visually, both within my sprint and across sprints. And you can totally do this with Azure boards. So the first thing that we're going to check out is the task board. So here it is. Here you can track what your team is doing within a sprint in a visual manner. You can drag it and drop it, and you can see what's going on. Super, super cool. Now, if we zoom back out a little bit, we can see at a higher level what a team is doing from the Kanban board. So this is a fully customizable Kanban board that shows the ongoing state of my project. And I really love this board because now in one place, I can easily see what's going on in my project. I can also see when a work gets stalled in a particular column, and when I notice that, I can now redirect my team. We can swarm on that particular unit of work. There's also deep integration between the work items created in Azure boards and also with GitHub. So let's go check out this deep integration between the two systems. So let's bring up GitHub. And if I make some changes to my file, all I need to do is format my commit message in a certain way. So let's pretend I'm doing work for work item number, how about work item number 425, all right? So in my commit message, I just need to say, let's say doing some stuff, this is where the magic happens, fixes AB pound 425. Now, check out what happens when I click the commit buttons. Look at the board, and bam, did you see that? How cool is that, right? The work item magically flew over to the done column because of that deep integration with GitHub. But wait, there's even more than just that. Let's take a look at this work item. This work item is now linked to the specific commit in GitHub. If we click on this, it's a deep link into GitHub that will take us directly to our comment or our commit. And now we can see exactly what we did in the GitHub UI. Super, super cool. This deep integration between Azure boards and GitHub makes working really, really nice. Okay, Tailwind traders, they're now almost ready to start diving into code, but they still have one process question, which is what branching scheme do they want to use? Now, traditional branching schemes involves a lot of long-living branches. So you've got dev branches, QA branches, feature branches, UAT, main, etc., etc. And having all these long-living branches, it's not conducive to moving quickly. Like anytime you need to merge code from one long-term branch to another, boom, a merge bomb goes off. And guess what? Sooner or later, you're going to get a code conflict. And fixing these merge conflicts is not easy or pleasant or quick to do, right? This is extremely painful and an expensive problem that everyone will run into if they use long-running branches. So to solve this problem, Tailwind traders, they've decided to use trunk-based development, where they're basically deving and releasing right off the main branch. So the way they do this is when a dev picks up a user story, they create a topic branch, do their initial work, and they very quickly merge that topic branch back into the main branch. With no long-running branches, there's almost no merge bombs. And any conflicts that do exist, they can be solved really, really quickly. So easy peasy, right? Problem solved. But some of you might be thinking, how can this possibly work, right? If you're practically deving off the main branch, how are they not just introducing bugs all over the place? They solve that problem by using a software technique called feature flags, or feature toggles or switches. So feature flags is a technique that lets you turn on or off certain portions of your code during runtime. In one deployment, you can now ship alternate code paths. And during runtime, you can pick which path you want to go. So this is awesome because what that means is you've now separated deployment of your code from the delivery of your new features. So this starts making things super, super flexible. Because of that, every new feature and every new bug fix Tailwind traders writes, it must be wrapped in one of these flags. So now they can check into master without fear. As long as a flag is off, the new code does not get run, only the old code. All right, from a code perspective, there really isn't anything magic with feature flags. They're glorified if statements. Wait, actually check that. They're not glorified if statements. They are literally if statements. They really are super easy to implement. So I've come across a lot of companies when I tell them about feature flags, they'll be like, oh, feature flags, it looks really cool, right? But we're not ready to use feature flags. Our application isn't architected in a way to support feature flags. That's just ludicrous, because if your architecture supports an if statement, guess what? Your app, it's ready to use feature flags. And once you start using feature flags, you can now start doing some really cool advanced DevOps stuff. For instance, you can do things like A/B testing, where a percentage of your traffic runs in variation A and a percentage of your traffic runs in variation B. And now you can grab the telemetry and figure out which one is delivering more value, right? Very powerful. You can also use feature flags to do something called safe deployment, where you only turn on the flag for a really small percentage of your traffic. And you make sure everything still looks good and works for just that small percentage of your traffic. And then you can open up your flag a little bit more and make sure that works, and open it a little bit more until you're very sure everything is good, and then you can turn it on for your entire traffic. Finally, another thing you can do with feature flags that's super cool is if something goes wrong with your latest deployment, rollbacks become super easy. All you got to do is just turn off your flag and voila, you're done. The new feature, that's what rolling out is. That's all it takes. All right, so enough talking about feature flags. Let's see them in action. So what you're looking at is my resource group in Azure that holds the resources for this particular project. And one of the resources is going to be an app configuration, right? So this will hold all the configuration for my application, including my feature flags. So to look at my flags, we'll go to feature management, and notice I have one feature flag right now, and it's called the new about flag, and it's currently in the off position. So if we jump to my application and we refresh this, okay, here it is. Look at across the top, there's an about tab, and it just says about. If I click into it, that's my current about page. Hooray for that. All right, let's jump back to the portal, and we're going to turn on our particular flag. So here's our portal. We'll turn on the flag. That's all it takes. Now let's jump back to the application, and we'll refresh. And now check out the about. Instead of about, it now says new about. And if we click it, it takes us to the new about page. Pretty cool, right? All right, so as you can see, these feature toggles, really easy enough to toggle it on and off while your website is running. So you can also do this programmatically as well, turning the flags on and off using the CLI. Now to implement, super easy to do as well. So let me show you. Here's my code. You can implement your flags both in the view and also the code. So let's check out the view first. This right here is your standard .NET view. You can add a feature flag by adding this tag, the feature tag, with the name of your feature, and with negate is equal to true right here. What that means is if the flag is off, then go ahead and output this chunk of HTML. Otherwise, if the flag is on, the new about flag is on, output this chunk of HTML. So what this is saying is if the flag is off, just output about, and if the flag is on, you output the new about, right? That's what we saw. All right, so in my code, this is how you would implement it in code. So I'm using .NET, and these flags are supported in a bunch of different languages. You can do this in two ways. First is by adding this annotation to an action in your controller. So if the flag is on, this action, it will exist. And if the flag is off, this action, it won't even exist. You can also do this inline with the if statement. So here I can say if, and I use a feature manager object, if it's enabled, and I pass in the feature flag that I'm checking, and if that flag is enabled, go ahead and run this chunk of code inside the if statement. And if the flag is off, you do the else, right? All right, so to see this running, let's set a breakpoint, and we'll go back to the app, and we'll go ahead and trigger this. So let's jump to the home page, click on New About, and it will hit our breakpoint. Hooray for that. And now, when we walk over this if statement is going to evaluate, and you'll see that the flag is on, so it goes into the if statement and runs this chunk of code. Now, when we jump into the view, this is my about view. And if the feature is on, it's going to go ahead and output this chunk of code. And if the feature is off, like negate is equal to true, right, it's going to output this chunk of HTML. And if the feature is on, it's going to output this chunk of HTML. So, feature flags, they're super powerful and they're super easy to implement, both in your code and also up in Azure as well. All right, finally, Tailwind traders, they've got one thing that they're worried about, and that's quality. So moving as quickly as they will be moving, they're not going to have time to do full end-to-end functional testing. So they need to shift left and build quality into their app as they're writing it versus trying to tack on quality at the end, like the way traditional software is QA'd. So one of the things they did to improve quality is they're requiring every check-in to go through a pull request or a code review. However, they quickly ran into some problems with their pull request workflow. First, pull requests were getting lost in the shuffle. People would either miss or ignore pull requests and they would start piling up. Now, there are some amazing benefits with pull requests. But if you don't do them immediately and they start piling up like this, your dev work comes to a grinding stop. Now, another problem they had when reviewing the code changes in a PR is that they really wanted to see the changes running in a live test system. But that's a lot of work, because what that meant is for each PR, they'd have to build the app, package it up, provision the infrastructure they needed, configure it correctly, then they needed to deploy the app into the freshly provisioned infrastructure. And now they can finally see those changes. And when they were done with the PR, they really kind of need to clean up the staging environment too, right? Because otherwise they're just going to leave a giant mess. And that sounds pretty crazy. Like being able to do this for each PR, it would be awesome. But really trying to execute this would be a serious pain. I mean, who has the time or energy to be able to do this correctly every single time and to do it quickly? And that's where GitHub Actions comes to the rescue. So Actions, that's GitHub's workflow engine, where you can automate all sorts of things inside of GitHub. Just as an example, I created automation using Actions to help take care of Tailwind Traders' pull request problems. So to solve the problem of PRs stacking up with no one really knowing PRs are there or waiting for them, what I did was I created a swim lane in our Kanban board, and I called this pull requests. And now whenever there's a pull request, I'll have GitHub Actions automatically create a pull request work item, link it to the GitHub pull request, and I'll put it into the Kanban board into the correct swim lane and the column, right? So this way, it is readily apparent there are PRs waiting to be looked at, and if no one picks it up quickly, as the Scrum Master, I can jump down my team's throat until someone finally does it. But wait, there's more, right? Next, I'll have this action automatically build and package up my application. And then, since I'm using Azure App Service to host my app, I'll dynamically create a staging slot named after my pull request ID, where I then deploy my application. And then, since the URL to my staging slot is dynamic and changes for each PR, I use Actions to write back to my pull request with a link to my staging environment for this specific PR. So this makes it super convenient for the person reviewing the pull request. And finally, when the PR is closed, I'll be a good citizen and my action will go up, clean up, and delete the slot from Azure App Service. So this sounds kind of nuts, right? But we can totally do it. Let's check it out. So what you're looking at right now is all the resources for this specific application up in Azure. One of the resources is the app service hosting this application. So if we go ahead and look at the deployment slots for this specific application, we'll be able to see that I have one slot right now specifically for production. All right, let's jump into the Kanban board. And you can see that it's configured exactly the way Tailwind Traders want. So they have an emergency swim lane for live site incidences. So again, this way it's super easy for them to see. The team can swarm on live site incidences and they can fix it. It's very visual, front and center. They also have a swim lane specifically for pull requests. So again, they were having trouble seeing when pull requests happen, and pull requests were getting lost in the shuffle. So this way, it's really easy to see. It's on their board, front and center. Team members can see it and jump on and start doing their PR. The rest of the board is configured exactly the way Tailwind Traders wants it. And okay, so let's go ahead and create a pull request and we'll make some code changes. So let's pretend this work that we're doing is for work item number 432. And instead of checking in directly, we'll create a branch and then we'll go ahead and create a pull request. And as soon as I create that pull request, it's going to go off and kick off that automation that I have. So let's jump into the Actions tab and we'll see the automation happen in real time. So here we are, automation's been kicked off, and now we can see in parallel, we're creating a new pull request work item inside of Azure Boards, putting it in the right place. Bam, did you see it? There it is. And we're also going to, in parallel, build my application, right? So when it's done building, it will then provision a new slot in my app service, and then it will deploy that newly built app into the provision slot. So this takes a little bit of time to do, so while this is running, let me show you how I configured all of this. Now, the automation is using GitHub Actions, and the way you set that up is off of your root directory, you're going to have a .github/workflows directory. And here's where you store the definitions of your workflows. And you're going to store it as YAML files. And I know nobody really loves YAML, but this one's pretty easy to understand. So first, you're going to name your workflow. So it's called name. And next is the on section. That's going to be your triggers. So I have two triggers. One of them is for pull requests. So anytime somebody issues a pull request to the master branch for open, synchronize, reopened, or close, it will go ahead and trigger this specific workflow. There's also another trigger called workflow dispatch, and this is just a manual trigger that I trigger from the UI. So I can use this to help me debug this workflow. The next section is my jobs, right? So the first job that I have is let's go ahead and create my pull request work item inside of Azure Boards. So that's what it does. Next, in parallel, I build my application. So I restore my packages from NuGet, I build my app, package everything up, I upload that package as a zip file back up to GitHub. Hooray for that, right? It's just a normal build. And now for my deploy stage, this is not going to run in parallel, right? Because I need to wait for the build to actually finish. So right here where it says needs build, that's where I'm saying wait until the build is finished, then go ahead and do your tasks. So what is this one doing? It's going to download my build artifacts. Then it's going to go ahead and get my pull request values from GitHub. So things like the title and the ID. And then I'm going to use the Azure CLI. So first I log into the Azure CLI. And then using the Azure CLI, I can create a deployment slot that's based off of the pull request ID. And when that's done, I can deploy my app into that specific slot. And when that's done, that's when I can go and create a comment into my pull request. So that's what I'm doing here. I create a comment back into the pull request into GitHub, and I give it the unique URL to the dynamically created slot. All right, and when I finally close this pull request, it's going to go ahead and clean everything up by deleting the correct slot. So it does that by getting my pull request values, then using the Azure CLI, I go ahead and delete what I need. All right, so let's go back to my actions, and we can see that it looks like it's completed. Everything is green, that's good. So now let's jump back to the browser, and we'll go ahead and check out what really happened in our environment. All right, so first let's go back to the portal, and we can see, let's refresh this, and bam, there's a new staging slot with the ID of the pull request. All right, so now if we go back to our Kanban board, we'll be able to see that it's created a new work item, right? And if we click on this, this will take us into the work item. And this is super cool because you can see that there's a link. There's a deep link back into GitHub. So this links us back to the GitHub pull request where now you can see it's adding a brand new comment. So we can click on it and we'll see, dun dun dun, we added a new comment that says created staging environment with a URL to my staging environment. So this makes it really easy for whoever is doing my PR. Now, if I click on this link, bam, it takes me to my app running in my staging environment just like that. How cool is that? All right, so not only does it do all of this, it does clean up, right? So if I go ahead and close this particular pull request, let's check out what should happen. It should clean up my staging environment, right? But again, automation is going to kick off, so we'll jump into actions. And you can see there it did. Automation has kicked off. And if we drill into it, we can see that it's now closing my pull request and cleaning up my staging slot. And it does that by deleting the correct staging slot from my Azure App Service. Again, this takes a little bit of time to do, so we'll go ahead and wait until it's done. All right, it's done. So now if we go back to the Azure portal, let's refresh this, and voila, the staging slot has now been cleaned up. Very, very cool stuff. Okay, so what I wanted to demonstrate with this specific demo is that I wanted to show that we can create a very intricate and complex workflow using GitHub Actions. And because Actions is so flexible, you really can make these workflows do just about anything, not just CI/CD. So go ahead, go and create automations to help enable your workflows. So this is super cool, man. Tailwind traders, they're now in a really good state. They have adopted the DevOps mindset. They've picked the products that will help enable DevOps, and they've implemented processes that will be doing what they need to do, right? So they've got everything now. They have the culture, the people, they have the process, and they have the tooling. So now the fundamentals, they are all in place, and they're now ready for some more advanced topics. So join us in our next session, Delivering Change in the Cloud, and we're going to dive into ways Tailwind traders can deploy into the cloud both faster yet safer. So we covered a lot today, so let's do a quick recap. At a high level, we covered how Tailwind traders will be running their projects using Agile and the Scrum methodologies. And Tailwind traders, they're going to be using trunk-based development with feature flags to be able to move at DevOps speed. And finally, using GitHub Actions as an automation engine, they've automated a fairly complex pull request workflow to help them move quicker yet safer. Now, if you would like to take a deeper look into all these DevOps concepts and more, head over to aka.ms/allthingsdevops, where you're going to find our DevOps Resource Center. Also, to get certified with AZ400 certification, head on over to aka.ms/AZ400cert. And to prep for the exam and to learn all the DevOps techniques in AZ400, head on over to aka.ms/gettingstarteddevops. And finally, to learn all things Microsoft, head on over to microsoft.com/learn. All right, thank you all so much, and I'll see you in the next session. About a part of DevOps, which is delivering change to the cloud. Now, Tailwind Traders, it's an online hardware store, and their software delivery team and engineers, they've been getting much better at working as a team. They collaborate well using Microsoft Teams, and they consider security really early on in their process. And they even have continuous integration that runs all of their tests and ensures the quality of their code every time they check their code in. But when they make changes to their application, actually delivering it to customers, the deploying to production part, that's still really manual, and it gets delayed because it's really hard and it's super, super painful, right? It hurts every time they deploy because things break. So naturally, they start avoiding deployments. And after a bit, when they absolutely have to deploy, what was just one small change has now become lots and lots of changes, which of course just makes everything that much worse. And when the team finally does deploy, is all that work going to be worth it? And we really don't know until it's in the hands of our end users, right? Because we can spend a lot of time coding up features, and when it finally does deploy, our end users could be like, didn't really like that feature. And now we've just wasted all that time because now we've delivered zero value. So it's much better to fail fast and then course correct. Spend a small chunk of time writing code, quickly deploy, get feedback and telemetry from our customers, and if we are delivering value, that's awesome. Carry on, right? We can just going to go ahead and build our application and then run our tests. So if we come into the Actions tab in GitHub, we can see this workflow has been kicked off. We can drill into it. And we can see, yes, all it's doing is it's going to build our application and test it. It is not doing any deploying of any type at all. So let's go ahead and jump back into our workflow definition, and we'll add some actions that will do that deployment. So the first thing we're going to do is at the very end of this workflow file, we're going to add some actions to do some deployment steps, right? So the first thing we're going to do is we're going to add a .NET publish step. And this will create my deployable artifact as a zip file. So it's going to be my web app all packaged up and ready to be deployed. All right, so after this publish step, we're going to add another step that's going to deploy the packaged web app to Azure App Service. So notice we're going to pass in the publishing profile of this app service as a secret, right? So we need this to be able to deploy. And we're also going, let's add one more task in between this. I want to be able to upload my build artifact to this specific release because potentially I want to do something with this build artifact later on in this workflow, maybe like in another job, right? All right, so we've added that. We'll go ahead and save our changes, and we'll go ahead and commit these changes back up to GitHub. So again, this is just your normal GitHub workflow. We'll do a commit, and then we'll push. And once we push our changes up to GitHub, once the code hits GitHub, it's going to trigger our action. And let's jump into GitHub and see what it's doing. All right, so here's our action. It hasn't started yet. Let's click on Actions again. And there it is. Awesome. Our action is running. We can click on it and we can see in real time everything that it's doing. So this takes a little bit longer to run because not only are we building and testing our application, we're also deploying as well. So as this is running, let's talk about some of the other options you can do inside of your build. So GitHub Packages is super useful if you are creating a reusable package that you want someone to download and use later. So things like Docker containers or NPM or NuGet packages, right? This is a great package management system, easy enough to use and add into your workflow. Another thing you can do with your build artifacts is you can upload it to a specific release. So this will allow you to upload your artifacts to a specific release as a downloadable artifact. And you can do that inside of your GitHub Actions workflow. And then you can download and use the artifact later on in your workflow, like for instance, in another job somewhere. So here's an example of how you can do that. All right, in terms of deploying to Azure, there's all sorts of things that you can do with Azure as well. You go to the marketplace, search for Azure, and you're going to find piles of actions of things you can do inside of Azure. What's really cool is all of these actions, the ones written by Microsoft, they're open source. So the source code is checked into GitHub, and you can read the code to see what they're doing, or you can even submit pull requests if you want to add features or to fix things. There's also a lot of documentations around how to use these actions. But one of the best pieces of documentation is examples on how to use these actions in real YAML files. So if we go ahead, let's go ahead and scroll down over here and click on Azure Starter Templates. Here you'll see plenty of examples of workflow templates that actually use real Azure actions. And if we click on Azure App Service, now we're going to see a bunch of workflow definitions as YAML files for Azure App Service. So if you're going to do something, we probably have a sample that we can use. All right, jumping back to the build, we can see this process, it's almost complete. We've built our app, we've uploaded our artifacts, and now we've deployed our application as well. So if you look at artifacts, bam, there we go. We've really deployed or uploaded our artifacts back up to this specific deployment. All right, so now if we jump into production, we should see our changes, right? So let's refresh this, and instead of recommended, bam, it says recommended categories. Our change has now been pushed all the way out into production. So all we needed to do was check our code into source control, and automatically those changes were built, tested, and deployed into production. And that's great, right? But maybe we want to deploy this same app to lots of different environments, maybe even host it in different places, like maybe host it in Azure and also in our own data center, or maybe even in someone else's cloud. So guess what? Containers, they're a great way to do things like that. So we're going to remove all of this, and we're going to replace this with Docker commands. So what are we doing? We're going to build our application in a container, then we're going to containerize our application, then we're going to upload our container image into a container registry. So let's go ahead and do a commit, and we'll push these changes back into GitHub. Now, once we do that, that's going to, of course, going to kick off our action, our workflow, and it's going to run using this definition. So what is it doing? It's doing something pretty simple, right? It's going to go ahead and build our app in a container. It's going to create our application in a container. It's going to create an image for that, and it's going to upload our container image to a container registry. So let's jump into the Azure portal. We can look at our container registry. You can see we already have some container images here. That's awesome. And now if we jump back to the workflow, as soon as it's finished, that means it's uploaded our container image up to our container registry. So jumping back into our portal, this is our container registry. Let's refresh this. And now you can see our workflow added a new image to this repo. Now we've tagged our images with latest, if it's the latest build image, and also with the SHA from GitHub. So everything is super traceable. And we also have an Azure App Service that's connected to this, and it's pulling images from this registry. In fact, every time there's a new latest tagged Docker image, it will automatically pull it down and deploy that Docker image into production. So bam, there's our code running up in production, just like that. So this is a super cool way, a super cool workflow of getting our code into production by using containers and container registries and hooking Azure App Service up to our container registry. Okay, so we've seen a couple different examples of pushing to production, but we probably don't want every one of our changes to go straight into production. Now, if we follow trunk-based development practices, working mainly off of trunk, then any commit to main branch, that's going to deploy to production, right? But we don't want that, at least not initially. We want some opportunity to verify that our changes look good and it doesn't break anything. So what are we going to do about it? We've spoken in other sessions about working with pull requests to make sure there's an opportunity to check any new code before it gets merged into the main branch. And as I've mentioned, there are dozens of events that can trigger workflows, and pull request is one of them. So now during a pull request, we can build that app, test that app, then we can deploy that app into a staging environment that's specific for that pull request. So now we can test the outcome of our changes before it's merged into the main branch. Or in other words, we're applying checks before merging back into the main branch. So there are quite a few trunk-based pull request workflows that work really well. But here's one that I really like. So this blue line here represents our trunk or our main branch. And as work gets done, a short-lived feature branch is spawned and work is done in there. So these short-lived feature branches, they represent the work we are doing, and it's important that they are short-lived. We don't want these branches to live for a long time. We don't want a month's worth of work stacking up inside these branches, because that's when merge bombs happen. So we're really talking about days here, max. Now, when we are ready to release or deploy something to production, we can create a release branch off of the main branch, and this will be used to deploy our code. And you can do the same thing with tags or with the releases. I really like using branches because branches are super cheap in Git, and it's also a nice way to archive everything that changes. And also, if we need to do hot fixes, we already have that branch ready to go. All right, let's take a look at pull request workflow in these short-lived branches. When we do a pull request, we can run a workflow, and at the end of that, we can deploy our application into a separate environment for each and every one of these feature branches. Now, when these short-lived branches, we can merge them into the main branch. And then we can have workflow that will go ahead and build and deploy from our main branch. So this automation means all we need to do is submit a pull request, and the newly running code that is tested on is then deployed. And when you do a merge into master, you get the running application in a certain location as well. But that main branch, what does that mean? Does that mean it will go into production every single time? So that is one option, but you never know for sure if the merge is going to work exactly as planned. And more importantly, you don't know if that merge will provide the value to your end users, which is what DevOps is all about. So what we really want to do is test our changes before we go into production. So one way to do that is we can pick these deployments off of main that work and promote them to the production environment. So our main branch doesn't deploy to production. It goes to some staging environment first, and when we decide this specific release should go to production, we can release that. We can create a release branch and promote that specific change all the way out to production. Now, there's a number of ways to do trunk-based development, and all of them have their pros and cons, and this just happens to be one that I like. There's also a lot of different ways to promote these deployments into production. The important thing is you should be deploying the exact same artifacts from one environment to the next, right? So I said this carefully. Make sure you listen to what I say. You shouldn't have to rebuild. We really need to use the exact same binaries that we deployed in our staging environment and promote those exact same binaries into production. All right, so yes, there are a lot of ways to do this promotion. But one super cool way that I want to show you all is using a technique called ChatOps. ChatOps is using your chat application, whatever that may be, to control your deployments in a nice way that keeps you in the tool that you're using in your collaboration. So next, we're going to implement ChatOps. We'll use GitHub Actions, since our code lives in GitHubs, and we'll deploy using Azure App Service, since our app is hosted in Azure App Service. And of course, we're going to use Microsoft Teams as our chatting app. And as we saw in the Getting Started with DevOps session, Microsoft Teams is an amazing collaboration hub for Tailwind traders. And we can add even more collaboration features into it by implementing ChatOps through Microsoft Teams. So first, let's look at how we can implement something like this with Azure App Service. Now, App Service has this really cool feature called deployment slots. You can think of deployment slots a bit like a shadow version of your app. So it shares an app service plan, but it's a completely new instance of your front end. But you can direct some traffic to it. So it's a great way to deploy your application because it's essentially you're deploying into production, but it gives you a chance to test things out before pushing it live to all of your users. Now, initially, maybe you have 100% of your traffic going to the production slot and you deployed into the staging slot. Then you can test out the staging slot, and when you think everything looks good, that's when you can swap those slots around. So now all the traffic is now being redirected into your staging slot, and what was your production, that can now be your new staging slot. So this is a really nice way to implement a blue-green environment. And swapping slots is super easy too. You can do that from the Azure Portal UI, or you can use the Azure CLI. Another thing you can do is direct some of your traffic to the staging slot. And this will allow you to test it and let some of your users see the new code just to make sure everything is okay. And if it's not, only a small portion of your traffic saw that bad code. And it's easy enough to swap that out, right? So next, you can slowly, if everything's working, you can slowly open that up traffic to more traffic and then to more traffic until eventually 100% of your traffic is now using that new slot. So something like this is you can use for canary deployments, or this is also like doing safe deployments. And using slot is a great way to implement this. You can also implement this in different ways, like using feature flags, but slots, super powerful. You can totally do canary deployments and also safe deployments. But how are we going to trigger this swapping, right? We're going to do that inside of Microsoft Teams. As we saw in Getting Started with DevOps, Microsoft Teams is a great hub for team collaboration. It's not just for chat, and it's not just for calls and sharing documents. There are lots of extensibility points that allow you to really use it as your hub for anything project related. Now, there are piles of wonderful stuff available with conversational bots, with customizable tabs, messaging extensions, so on and so forth. But for our purposes, we're going to be talking about connectors and webhooks because that's what we need to really integrate with GitHub and Azure to help with our delivery, our software delivery. And now we can do all of this without leaving Microsoft Teams. Also, we'll be using a cool features inside of Teams. Instead of just dumping messages in the channels, we're going to use something called an adaptive card. So these can give you powerful interactive containers so you can actually do work and make things happen rather than just see status updates. All right, so here's the plan. When a PR is merged into the main branch, this is going to kick off automation and will deploy the build to a staging slot. Next, GitHub will go ahead and send a message to Teams that a new deployment just occurred using an adaptive card. And this will say a new deployment occurred. It will have links to the new staging slots, and we'll have a button that will promote your changes into production. So after seeing this message in Teams, you can go directly to the staging slot, test everything out, make sure everything looks good, and if it does, then we can click that promote button, and this will trigger the promotion or the slot swap, and then the staging deployment will be promoted to production. All right, super cool. Let's take a look at this in action. We'll walk through this workflow using Tailwind Trader's website. Again, we need to make some changes, but this time we'll be a little more safe with our deployments. We'll deploy into a staging environment, test it out, and then promote those changes into a production environment. In fact, we're going to take this one step further and go through a pull request first. So here's our website again, and this time the finance department came to us and said, this free shipping that we're doing, that's not going to fly, man. It's costing us too much money. So instead of free shipping, they want us to change it to cheap shipping. All right, easy enough. I've made those changes already, and if we jump into VS Code, we can see some of the changes that I've made. And I've made these changes in the cheap shipping branch. And when I checked this branch in and issued a pull request, this kicked off my automation, which built this branch and then deployed it into staging. So this is my production branch, and as you can see, the changes did not deploy to production. It deployed to my staging pull request site first. So here you can see in our Teams channel, GitHub alerted us to the pull request. And that came from the GitHub Enterprise connector. So here's where we configure our connectors, and we configured this to send events from GitHub, our project in GitHub, to this specific channel. All right, so now, if we click on the View in GitHub button, this will allow us to view the pull request directly in GitHub. And here we can see exactly what changed, and in this case, we changed free shipping to cheap shipping. All right, we can also see this build kicked off our pull request build workflow. So clicking on the details, we can see exactly what happened in this workflow. Now, part of this workflow, it deploys this to a pull request staging environment. And what we want to do is check that out, make sure it looks good, and see if this is something we want to promote to production. All right, so let's go ahead and jump to our pull request staging slot. We'll go ahead and refresh this. And free shipping then changes to dun, 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 cheap shipping. Yay, our changes hit our pull request slot. It looks good. So what we want to do now is merge these changes into the main branch. So let's just jump back into Teams, because now we can go directly to our pull request, and we'll merge this to our main branch. All right, so once we merge our changes, it's going to, of course, kick off our actions. And here we can see that it kicked off. And now we can jump in here and we can watch it run through. Right? There's an extra step configured now where we send a message to Microsoft Teams. So yes, it builds, it tests, it publishes, it deploys it, but it also sends a message to Microsoft Teams. So what that's doing is we're sending a message from here, hitting a webhook in Teams, and it's sending an adaptive card to our chat ops channel. So if we jump into the chat ops channel, we can see that adaptive card where it says deployment has completed. And there's also a deep link to the commit which triggered this automation. And if we click on this, it will take us directly to that commit in GitHub, which shows us exactly what was changed. Now, going back to that adaptive card, we can click on the open staging site, and this will take us directly to the staging slot. And you can see cheap shipping has made it to staging. Awesome. But it still hasn't made it to production yet, right? Hasn't made it to production. So now we can jump into the Azure portal, and in theory, we can just swap the slots here, right? But jumping around in different tools is kind of a pain. Plus, in Teams, we have that adaptive card, where if we press that Promote to Production button, if we click it, it's going to hit an Azure function, and in the background, it's going to use the Azure CLI to swap slots. And now we get an updated card that tells us the application was promoted to production, with a button to see the production site. So let's go ahead and click it. This will take us to production, and now we can see, let's refresh this, instead of free shipping, it's now cheap shipping. It's made it all the way into production. Hooray for that. So we're looking pretty good now. We have continuous integration. We have continuous deployment workflow. And it's using GitHub Actions, Microsoft Teams, and the power of Azure to make sure we're deploying our application out to Azure. But our production environment is now protected, and we have an opportunity to check it out in a staging environment before we promote those changes to production. All right, one thing we pointed out a bit in these demos is the idea of keys, secrets, and credentials, right? When you deploy your application, there are places you're going to need to pass in passwords and secrets to authenticate. For instance, when we deploy to Azure, we have to be able to authenticate with Azure. There are also keys and settings and credentials that our application needs just to run, things like connection strings, API keys, and these need to be set during deployment. So all of this stuff should not be in source control. In fact, GitHub will alert you if you accidentally leave a key in source control, right? Because now you're leaking out your secrets to the public or to a lot of people that shouldn't have them. So how do you handle secrets? Now, right out of the box, there are GitHub secrets. So in GitHub, for each repository, there's a place to securely store secrets that can be used in your workflow. Here, we're using it to store the publishing profile for our deploying to our staging site. Now, we have to create the secret out of band, so it's not in your code. It's safely stored in a separate location. Right. So to set this up, it's easy enough. Again, it's specific for your repository. You go into the settings, secrets, and here you can create a brand new one. Now, if you do this, you'll notice that there's no way to view these secrets once you stored them. You store them, they're encrypted, and now no human being will ever be able to look at them again. And even if you use them in your GitHub Actions, GitHub does its best to strip them from all the log files, so you still won't be able to see them. But as good as this is, there are some limitations. The secrets might be used in a number of places. So if they're changed, now you're going to need to change it in every single repository that uses this secret. And the key here is you got to remember where they all are. So this is particularly important in the case of an emergency or a security incident where you need to kill all your creds immediately and quickly recycle all of your secrets, right? Trying to remember where every place that uses them, that's really difficult. If you don't remember every repo, deployments are going to break, right? So it's also generally a good practice to cycle your credentials often. So now the person in charge of controlling these credentials, they also need access to every repo that uses them. So if this is your ops team, you can see this does not scale well at all. In fact, it scales pretty badly. So another great way to store your secrets, and not just your secrets, but your keys and certifications as well, is in something called Azure Key Vault. This can be integrated with your other Azure resources, giving us a central place to manage everything. So Azure Key Vault allows you to have a single point of control. And it's also managed by Azure Active Directory. So sensitive information is centralized and it's managed by the appropriate people. And the workflow simply pulls these credentials just before they need them and is using another Azure credential that can be controlled centrally as well. So let's take a look at what this looked like. Here's our workflow that uses Key Vault action from Azure to retrieve the Docker password from a specific Key Vault. It's stored in the output variable with the ID KV secret action. And then in the next step, we use that stored secret with the Azure Docker login task to log into Docker. So if we need to cycle our secrets, all we need to do is make those changes to our secrets in Key Vault. We don't need to make any changes to the workflows or in any of our repositories. They will just work. They will just pull those secrets down and everything flat out works. All right, so let's take a look at this in action. Again, we'll be using our Tailwind Traders website. So we're going to jump back to our first demo, and just after we change our workflow to use Docker for our deployment. So what we're going to do, what currently it's doing, it's using a Docker password that's stored in secrets in GitHub. And we want to change that by pulling these from Key Vault versus using it directly from GitHub secrets. So to do that, we'll add a couple of actions here. The first, we're going to go ahead and log into Azure, and we'll use the credentials that are specific to this application. So if they need to be reset, we can just reset it for this specific application. After logging into Azure, we want to get the Docker password from Key Vault. So we'll use the Azure get Key Vault secrets action. And finally, in our Docker login, instead of using the Docker password from GitHub secrets, we'll use the secret from Key Vault by referencing the output variable in Docker password. So again, we're logging into Azure, we're getting the specific secret from Key Vault, and then we'll use that secret, and then nothing else has to change. So let's go ahead and commit this, and we'll push those changes back up to GitHub. Okay, so once those changes hit GitHub, it's again going to kick off this action using this specific workflow, right? So this right here is Key Vault. You can see we have our Docker password, and we can also see that this is a place that you can store your secrets and also your keys. Now, it turns out I don't have any secrets or keys or certificates, but if you had some, you would store them here, right? All right, so we have no keys, we have no certificates, but we do have that one secret. All right, now jumping back into action, we can see that our action has kicked off and our workflow is now being triggered. Now, if we jump into this workflow, we can see that it's running. And again, it's not doing anything magic here, but this time, instead of getting our secrets from secrets in GitHub, it's pulling the secrets down from Azure Key Vaults, and then it's going to go ahead and use it. So we've seen some pretty cool things with GitHub Actions and Microsoft Teams and Azure App Services all working together to enable us to deliver change to our customers. But we can do so much more too, and our imagination is really the limit here. So we can do all sorts of stuff in our automation tools. So for instance, maybe we want to rotate the credentials in Key Vault for our app. And maybe we want to do this when an admin just asks the team bot to do it. Guess what? We can do that using integrations with Teams to hit the Azure API, rotate the credentials. And the next time we deploy our app, guess what? Everything just works because our workflows pull these secrets down from Key Vault. Maybe we want to automatically build a new developer environment and fork a repository into their private repository based on a properly formatted issue in GitHub Issues, right? So this isn't something that I'm just making up. I've actually seen this happen. So there are people where if you create an issue in a specific private repo, it will automatically create all of your resources up in Azure using ARM templates, and then it will fork that repo into your own personal account. So now you're ready to make changes and fix this particular issue. All right, we can also do things like pull the commit messages since the last production release, so we can automatically build release notes, right? So our imagination is a limit here. With Actions, we can have workflows that automate just about anything inside of GitHub. There's also a repository dispatch event that can be used for any external application. So if you registered this correctly, any external app can now fire repository events to GitHub, triggering your actions. So we've covered a lot of stuff here. So to summarize, add CD to your pipeline, whether it's continuous delivery or ideally continuous deployment. I think it's important to continuously deploy somewhere. It doesn't have to be production, but continuously deploy to a test environment is super valuable. It means not only have you built your app and your tests passed, but you also know your app will deploy successfully. And moving to production will probably work because you've already done this in your test environments. And if you use containers, you can feel even more confident things will just work. Ultimately, though, it's about protecting production. You don't want to deploy all your changes directly to production, and one way to do that is using ChatOps. By using Microsoft Teams and its integration points, you can send adaptive cards that will allow people to do work of promoting changes to make sure the changes are working. And finally, I think it's really important to centralize your secret storage like using Azure Key Vault. Yes, you can put your secrets directly into GitHub Secrets, and you absolutely just don't want to put it in source control. That's the key. But putting all of your secrets in Key Vault, that means you can manage them in a much cleaner way. And if you want to learn more about what we've talked about today in this session, go here and do this Learn Path, which will teach you how to author automations using GitHub Actions. Similarly, if you want to learn how to collaborate with teams and you want to learn how to do that, here's another great Learn Path that does that as well. So go ahead and check that out. Also, there are plenty of documents on Microsoft Docs, so go here to see all the docs about the Teams integration and writing those Teams integration. And if you want to learn about Azure Key Vault, jump in here, and there's all sorts of docs and learn modules about Key Vault. And finally, thank you all so much for joining me. Hopefully you learned some great DevOps information, and stick around to the next session because we're going to do even more cool DevOps. Thank you.
Learning journey up with learning how we can improve the notification and response, as well as improve build consistency and repeatable automation. Now, it's no surprise that security and compliance are core concerns for organizations. Adopting DevOps practices and delivering software faster can increase those concerns. Now, there's key steps we can take to increase security and compliance as part of our DevOps lifecycle. This is what we're going to focus on in Module 4. Let's check it out. Hi everyone, my name is Jessica Dean, Senior Cloud Advocate at Microsoft. And today we're going to learn how easy it is to build in quality to our DevOps process. Now, real quick before we dive right in, let's do a recap of this DevOps learning path, or learning journey as I like to call it. First, we learned how easy it was to get started with DevOps. We learned about what DevOps actually is. Then we built on top of that and we learned how easily we can manage the flow of work. Finally, we ended the first part with how we can deliver that change. Now, today where we're at is where we're learning how we can actually build in quality. That's this session. And then as we talked about, we're going to wrap all of this up with learning how we can operate software in the cloud and how we can continue the journey after we're done delivering our DevOps pipeline. Now, let's just go ahead and level set and define some clear goals for this session. First, we're going to learn how we can consider security and how we can handle secrets. Then we're going to learn how we can apply that security to containers, right? We're in this world of microservices and abstracted systems, and security sometimes gets overlooked, or honestly, there's a lot of confusion that falls around that. And we're going to learn how easy it is. And then we're going to end all of this with how we can build quality and gain confidence in that quality that we have built. Now, by now, you've probably seen this Tailwind Traders website, right? It's a simple front end. We have ASP.NET. We have React built into it. There's some services that are in the background in Azure. This is going to be the same website that we work with today. And we're going to learn how, again, we work with it in containers. So just a quick overview of how this actually works. Right now, we have Tailwind Traders in a Docker container running an app service. It still connects over to Azure SQL Database and Azure Cosmos DB. But there's a few things that Tailwind Traders needs. Certain things aren't quite working the way that we need for scale. First, we need to increase the level of quality we have, especially with the growth that we've recently seen. We need to have confidence in that quality that we're building, especially that we're now in this container world. There's a lot of things that we're not quite seeing, and we need to be able to have confidence in that. And most importantly, or also in a line with equal importance, we need to also have security. We need to make sure that we're still embracing security despite our move to the cloud and our journey with DevOps. So what we want to end up achieving is having our Tailwind Traders website more abstracted. And this isn't just a Kubernetes or Docker or container thing. This is more of an architectural design. We're going to abstract out our framework. We're going to go from this monolithic application. We're going to decouple our APIs, and we're going to start having microservices with backend APIs and web frontends. In fact, when we're done with this, there's 11 different microservices that now we have to manage. Now, this is going to empower and enable our developers to be able to react that much quicker, to be able to debug just one broken API. Maybe it's the shopping cart, maybe it's the products database or the login. But now we'll be able to focus on just that one component. And even though everything's decoupled, it's still going to correspond with our same SQL database that we have in Azure and our same Azure Cosmos DB. So let's start off with the first part, security and vulnerability management. How do we handle this in this new world? First, it's no secret that when we start having different packages and different NPM packages or NuGet packages, if we take it from the source, if we take it from whatever our upstream is, there's going to start being something that we don't understand. There's going to be some vulnerability that might be hidden in there because we haven't had any kind of control, or we haven't had any kind of insight into what actually is the life cycle or the history for that package. This is where we get to tie in GitHubs to this. GitHub offers community-powered security and compliance. It gives us dependency insights where we can actually see that history for that dependency for that package. We get things like real-time inventory. We can see license compliance. Is it that this package actually is in compliance with the licenses it claims to have, or is something else going on in the background? We even can get vulnerability alerting. We also get to take advantage of vulnerability management. Now this is super cool. We get to take advantage of code scanning, secret scanning, so we can make sure that we haven't accidentally embedded a database connection string or plain text password or something like that in our packages or in our application that's now running in production. In fact, GitHub Actions offers the largest vulnerability database. We're even able to set up and configure, if we want, automated security updates. Finally, we're also able to take advantage of CodeQL, which is the world's most advanced code analysis. It actually allows us to hunt vulnerabilities, and it's built with community. Community is a key focus here. We take top security experts and we're able to improve the security and compliance and confidence that we have in the security. Confidence is going to be a key theme you hear throughout this module. So first, with vulnerability management, there's actually over 62 million security alerts that are set across GitHub. And we get to have visibility and insight into this right from within our GitHub project, within our GitHub organization. Code scanning, as we talked about, allows us to find and fix vulnerabilities fast. We talked about the community of security experts, and it's integrated with developer workflows that we're already using. Since Actions is built right into our repos and our projects, it's very easy to turn on and enable. So let's go into a quick demo where we actually check out how simple it is to get started with both GitHub secret scanning, vulnerability management, and even taking a look at Azure security when it comes to containers and container images. The Tailwind Traders technical team is settling in on their new tooling. Work is moving across their boards, as we learned in the previous module, and now we're starting to get a sense of accomplishment after looking at these boards. But unfortunately, all is still not well. There have been several instances where new releases were deployed with vulnerable container images or missing settings flat out. In fact, in certain instances, we actually found passwords and database connection strings. Certain things were actually embedded and baked into those images as well. The team's leadership as a whole is also worried that since we're now moving at a quicker pace, since we're now able to sprint that much faster, are we really taking the time necessary to review our code as thoroughly as we need to? Or are we sacrificing code quality and doing defensive coding in the name of cycle time and just trying to hit that deadline? In an effort to address these concerns, our team is going to investigate what we can do. We've identified that the first step is to turn on the security features inside of GitHub. By turning on dependency alerts and things like code scanning, we're able to target two serious problems we have. For one, we target outdated dependencies. Two, we also target common security practice violations in our code. Now we can couple that with Azure Security Center and vulnerability management for scanning container images, so we can actually sit there and say, okay, great. We've identified these outdated dependencies, but we've also coupled that with vulnerability scanning, and so we can actually say that this package or this dependency is unsafe, or this image is actually running as a root user and we need it to run as non-root. We can also use Azure Key Vault so that in the event that for whatever reason, a plain text secret of some sort gets baked into something, we can quickly and easily remediate and recover. So we're also going to tie that into GitHub secret scanning so that we can prevent that kind of security issue. In this first demo, I want to walk through the basics of how easy it is to add GitHub security features. Then we're going to walk through Azure Security Center vulnerability management, and we'll even take a quick look at just how easy it is to rotate secrets using Azure Key Vault in the event of exposure. Now, this is especially important because Tailwind Traders, as you've seen in previous demos, in previous modules, is written in .NET and React, and we previously saw both were used in one web-based application. However, when we decouple it and break out the app into more of a microservice architecture, now we've broken out the APIs. We've designed it as 11 different microservices, which means 11 different images and 11 different possibilities for failure. So let's go ahead and take a look at this demo. First off, I have the Tailwind Traders backend up. And you'll notice if I actually drop into the deploy folder, you're going to see how I have a Helm folder. I have ARM templates folders. I have demos. I have different components in this repo. But specifically in Helm, which is the de facto package manager for Kubernetes, it's how we're easily deploying each one of these APIs, these microservices, and therefore each associated image. We can see we have the cart API, the coupons API, the image API, the login API, and all these different services, 11 different ones total, all kind of broken out. Now, if we go back up to the root folder and we take a look at the source, we'll see that we also have code base that lines up with those same services as well. If we simply drop into the services folder, here we have again our cart API, our coupon API, our image classifier, and so on and so forth. So we really want to scan everything in here. And after we take our Docker files and our Helm charts, which reside in the root directory, you can see one right here, of each service API, we're going to want to make sure that we also scan those images to make sure that nothing is baked into them, to make sure that there isn't anything vulnerable in them. But first, we want to start with code scanning and dependency scanning. So there's actually a few ways we can get started. First, if we click on the security tab, one of the things we can do is set up a security policy. Now, this is going to define how users should report security vulnerabilities for this repository. And what I really like is when you click on Setup and when you actually click Start, it gives you a nice little markdown sample. And if you just want to preview what that sample looks like, you can actually sit there and identify which versions have been vetted by the security team or by your vulnerability scanning as being supported or not supported. Now, if we go back over to the Security tab, once you define your security policy, you can take advantage of security advisories. Now, this repo doesn't have any, but I want to show you what security advisories look like in the context of a real-world project. Let's take Helm, for example. It's an open source project. We have companies around the world that contribute to this project, and as a result, it's also an area where there can be a great deal of security concerns. So if we take a look at the security concerns that currently exist for even projects like Helm, you can see any known security exploits. You can see that there's a plugin archive directory traversal, which versions are affected. You can identify publicly to your repo and to your project which versions are patched, which security concerns were identified, and the severity level. If we go back, we can see that we also have two more. So for example, if we take a look at the CVE here, you can see that this has a high severity level. This is one of the great features that's, again, built directly into GitHub that you can then utilize in your project. Now, if we go down further in the Security tab, you can also set what's called Dependabot alerts. This is a way to get notified when one of your dependencies has a vulnerability. For example, when we click on Enable Dependabot alerts, you're now guided over to the security and analysis part of your project settings. You can either click on security and go there, or you can click on settings and navigate to security and analysis. Either way, you can enable Dependabot alerts and you can opt in to easily upgrade non-vulnerable dependencies, which means you can have GitHub actually take care of that upgrade and that security remediation for you. The last thing I want to highlight in GitHub is code scanning, which is where you turn on code scanning, which will automatically detect common vulnerabilities and coding errors, which help us be more proactive as we develop. You just simply click on Setup Code Scanning, which is in public beta at the time of this demo, which means you might have to sign up for the public beta. But once you do, you'll be able to set up different workflows. This actually works hand in hand with GitHub Actions, and we'll learn a little bit more about GitHub Actions in our final demo in this module. Now that we see all the different security features that exist within GitHub itself, let's take a look at how that would actually translate after we turn these security features on, after we build our images and then push them over into Azure. Now I also have my Azure portal up here, and I already have Azure Security Center enabled. I've already drilled down into recommendations, and under recommendations, you can just type images, and you'll be guided over to the option where you can view your vulnerabilities in Azure Container Registry images that Azure is recommending should be remediated. Now you can see that I have 10 different repositories that are unhealthy and one repository that is healthy. That equals the 11 total microservices. You can see that some of my repositories have multiple scanned images, which is why, for example, over here, 3 images have been scanned that have vulnerable images versus maybe the cart API that says only 1 image has been scanned. However, in any one of these scenarios, you can drill down into the actual service itself. You can see which package or which digest and which tag was scanned. or the findings, in this case that it's red, which means we know that it has one high vulnerability. If it's medium, it would be orange, and low should be yellow. Either way, we can drill down into our digest and we can actually begin to investigate what the concern is. First off, if we actually zoom into our security check here, we can see that number one, there's a user with a blank password. And the Linux image also has a hard-coded credential. We can drill down even further to get even more insight into the actual problem. And I can see right here that the image actually has a null password for the user, for the root user in particular. Now, if we were to do simple changes, such as ensuring our container images are not allowed to run as root, we can then mitigate and solve that problem. And we can go through the recommendations for any one of those repositories within that particular container registry. We'll talk about how we can do little things to fix that and ultimately result in a healthy repository like we have with the one healthy repository that's for the popular product API, where there aren't any kind of vulnerabilities. In fact, you don't even get to drill down into the digest because there's nothing to investigate since it's just considered a healthy image. Finally, the last thing I want to show you in this demo is Azure Key Vault. Now, if I navigate to Azure Key Vault resource page, you'll be able to see in the overview, you can see monitoring, requests, latency. But what's really important here is actually on the right or the left. If you drill down into secrets, you can see any secrets that you have. Here's a database secret, for example, for Tailwind Traders. You can see the current version. I can actually create new versions based on new secrets. But let's talk about what happens in the event data is compromised. You can set activation dates, which means you can say all database strings for 10 different APIs can activate or need to activate on this date at this time, as well as you can set when those same strings or passwords or secrets expire. You can very easily roll in and either enable or disable those secrets. This is really helpful so you don't have to worry about having your real secret in plain text. Now, this secret can be anything. It can be a database connection string, a certificate, or really any secret. Your secret is backed by this new rotatable and easily mitigated, secure way of retaining your secrets. All right, wasn't that just fantastic? Talking about security and talking about how easy it is to just enable those little features is probably one of my biggest passions, because again, it gives us now confidence in this application we're building, but most importantly, the value we're delivering. So now let's talk about container security, because we briefly touched on that right at the end of that demo. Now, let's do a quick refresher on how Kubernetes architecture works, because to support these 11 different microservices and our abstracted APIs, we now have kind of increased or changed how we have our architecture, how we have our infrastructure. So Kubernetes in a normal scenario, maybe something that's not cloud, something that's not running in Azure, or maybe it is, but you didn't have your cloud provider set it up. It's something that is what's called self-managed. You're going to have your self-managed main node or nodes. So this is kind of interesting because you can have one or three. It depends on how highly available you want to make it. But in either scenario, that main node or nodes is going to have an API server. It's going to have an etcd database. It's going to have a scheduler, and you can have multiple schedulers. It's going to have a controller manager. It's going to have a cloud controller. This is kind of like the brain of your Kubernetes cluster. And then you have what's called your agent pool. These are sometimes also referred to as your worker nodes. Your worker nodes are going to be what's actually running your pods. And the little containers that we build run inside of pods. Some pods can have more than one container. Typically, you will probably have one, but sometimes you can have two. But either way, those pods are working because of the Docker engine or the container runtime. In this instance, we're using Docker. This is your agent pool that's now communicating with that main nodes. We can also call the main node or nodes your control plane. Now, you're going to have a Kubernetes API endpoint that you're going to have to send some sort of workload or instruction or definitions off to that then is going to communicate to the control plane, and that control plane can then communicate properly to the agent pool. And then we have us as the user, and the user is going to take that app or workload definition. It can be a manifest.json file, it can be a simple YAML file or collection of YAML files, or it can even be a Helm chart, which is personally, and also from Microsoft's perspective, the recommended way to hand that workload definition off over to your Kubernetes API endpoint. But as you can tell in this self-managed infrastructure, there's a lot of moving parts. There's a lot going on, and there's a lot that can go wrong. So how can we increase confidence in this process? Well, first, we can let Azure take care of the control plane. We can have an Azure managed control plane, which is what Azure Kubernetes Service is. So now you don't have to worry about hardware upgrades or canonical upgrades or anything like that. Instead, you as the user, whether it's the developer, the operations, or whatever your role is, can send off that workload definition, hand it on over to the Kubernetes API endpoint. Azure will take care of it and then schedule it accordingly to your agent pool or your worker nodes. Simple, right? Now let's do a quick refresher also on how container layers work. And this is important when we consider that container security. You're always going to have a base image. In this instance or this example, we have from Alpine. And then each blue block that you see or each block building on top of that is a layer. That's usually a line in your Docker file. All of those layers that gets baked into your image are image layers. They're read-only. Your read-writes actually happen at the container layer when you're running your container, be it you're running it in Docker or Kubernetes. But people forget, and even I've forgotten sometimes, that anything that's in your read-only is accessible at that container layer. That means things like your database connection strings, your SSH key pairs, your plain text passwords. So there's certain things that you want to consider as you're dealing with this, again, container building process. You can think of it kind of like a cake or a stack of waffles. And I like to compare containers to a waffle because all waffles do in reality is they're delivering some sort of happiness or joy. If you take the breaded part of a waffle and you just have it completely plain, chances are it's not going to deliver as much value, unless that's your preference, and that's great, but as much value as if you start adding value-add toppings. You add whipped cream, you add syrup, you add strawberries, blueberries, pecans. All of those different toppings are value adds. You're being very intentional with what you're putting on that waffle, and that waffle now becomes a delivery mechanism for that happiness or that positive end user experience. That's the same thing that a container is. But if you have a stack of waffles or a stack of cake as you see on the screen, you need to be very careful what you're baking into that cake or into that waffle. Okay, this is where it just kind of becomes very important to consider that, to be very cognizant of that throughout your build process. So in this next demo, we're going to learn how we can do just that, how we can be very intentional and how we can build secure containers. All right, so in our last demo, we saw that we have quite a bit of vulnerabilities that Azure Security Center helped us identify. So now we're going to take a look at the source itself and see how we can start fixing some of those. So the first API I'm working in, and we can actually drop down, you can see that I have Tailwind Traders backend open here. I'm in the source directory. You can drop down into services, and I'm currently working in the cart API. We have all the different APIs here, so we can start working in cart and coupon and image classifier. But I just want to change a few of them just so you can kind of see what we're going to work with here. Here's our Docker file. It starts out with our from image, which is kind of like our base image. We set a work directory, which is the folder that we want to work within our container. And remember, a container is not a virtual machine. A container isn't even a real thing. All it is an application delivery mechanism with process isolation. It's just going to help you deliver your application in the most valuable and safest, secure, most optimized way possible. But that kind of is dependent on you and how you structure your Docker file, right? You have to make it secure. You have to make it perform well. So we have to do things that's going to be optimal for our application delivery. So you can see our work directory. We're copying our package.json file over. This is obviously a JavaScript component of our application. Like I said, it's both coupled as React and .NET Core, but it doesn't matter the language. It matters, again, the structure of that application or that process isolation delivery system. So after we set up our packages, get any of our build dependencies, Python files, we copy our files and everything over, we're then going to run just our normal npm start command, and that's what we defined in our package. Package.json. So right before we actually start our container itself, right before we run it, we're going to add in one line that's called a user. And this is where we can set the actual user name that we want this to run as, or we can set the user level. If we set that user level to 1000, that's just a standard default non-root user, and that helps set us up to make sure that this container is not going to run as root. It's not going to run as a super user, and therefore it won't be flagged in Azure Security Center as a potential vulnerability. The other benefit for this is when you do have containers that run as root, they have the potential, in the event that there's malicious code in your application, of actually jumping out of the container and attacking the host. That is a little specific to Linux containers. If you're working with Windows containers and you have Hyper-V isolation, sometimes you have an additional level of security, but rather than focusing on the architecture from a wrapper perspective, you can focus on the security from the inside perspective, right? Doing best practices so that we can set ourselves up for success. So I'm going to do that on the cart API. I'll drop down, I'll do that on the coupon API and just a few others. You can see again, this is still Node. Right before the command, we're just going to do the same thing. User 1000, we're going to go ahead and hit save. Now, in certain applications, you might find that this isn't enough, right? Maybe you do have to do a little bit more, but taking the information from our vulnerability report allows us to go in and really see, is this something that we can implement, or how can we better mitigate this potential security flaw? I'll do it again on our image classifier and drop down into our Docker file here. You can see this one is actually .NET Core, but we'll still drop down. This is actually an interesting image, so you can take a look. First off, we're setting some arguments. That's why you see arg right up here at the top. We have our SDK tag, our runtime, our image. All of those are arguments that we're setting that we can actually change at build time. We can use the build-arg flag to override that, or we can hard code it in our Docker file as we're doing. And then we're actually using what's called a multi-stage Docker file. So this sets us up for even a greater success or even more additional success. This is just our base image. This is going to be what we actually need to start building our application or our dependencies. A lot of times what we need at build is not what we need at runtime. So we can have a safer and more secure image when we implement multi-stage Docker files, so long as it makes sense for the architecture of the application. We can build our actual DLL file prior to ever running it, and then at runtime, all we need is the runtime software, right? We don't need the actual SDK and the entire package. We can slimify or slim down that image. So you have our base image where we're just going to set everything up for what we're going to need. We pass that off to our build image. So now we're going to take our from and we're going to actually create our build DLL files. We're copying everything over from our build props directory, our build directory. We're setting a project working directory, and then we're actually running our .NET restore and our .NET build commands. And notice this line right here on line 26, this part where we do -o/app, we're putting that output in /app. And that's important because when we get down to not only publishing, we're again putting that in -o/app, but specifically our final layer. This is our final image. This is actually, these 5 lines right here is actually what's running in the container. You can see from base as final, we're going to copy from /app. So we're copying what we built and what we published. And then we're also copying our model files from our build. Any one of these, the build that we have or published corresponds to the name of whatever the name of the stages. So we have publish right here, and then we have build right here. So we're copying the output from that and then just running our application. So now our image is ridiculously slimmed down as opposed to just having all of this baked into one. So right before we actually run this, we can put down here, we're going to set that to user 1000 and we'll simply hit save. Now we could keep going on down the list and do this for all the others just to show back and let's take a look. Let's just remember the Tailwind Traders application and how much we've accomplished throughout these modules, right? We were able to first get our application into the cloud, into app service. We were able to decouple our application into several microservices. We were able to get it running in Kubernetes in Azure. We were able to tie in security management and all these wonderful things, right? So what exactly is next? Because we've deployed it. Well, first on our agenda is we're going to make sure that we have a responsible incident response set up. If everyone is responsible for incident response, then no one actually is. And we'll talk about what that actually means. Now, sadly, there's no magic people or machines. We can't just go in and click a button and turn on all these different features, as we were able to with a lot of things that we've learned throughout this learning journey here. So we're going to need to consider secrets, passwords, authentication. All of those things need to make sure that we have limited dependencies on specific humans, right? We can't just give everyone the keys to the kingdom or God mode. We also want to make sure that we're considering tooling over tasks. Rather than having humans be the bottleneck or the people doing manual processes, maybe there's certain things that we can actually automate, that we can help solve the problems more simply and free up the resources on our team. Now, even Jeffrey Snover, who's actually a technical fellow at Microsoft, and he's the creator of PowerShell, he has said a big message. He has said, in a lousy economy, nothing, and absolutely nothing is more important than automation. Productivity equals career security. So if we don't automate everything we can, and I'm going to repeat that, automate everything you can, not automate all the things, just everything we can, then we're going to be destined for failure. We're going to be destined to not be productive and not have career security. So we're going to learn why automation is important and how simple it is to automate simple tasks. So first, let's just recap and end this entire learning journey out with a refresher on the definition of DevOps so that we have clearly defined goals with DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And this is a quote by Donovan Brown. He was my boss, but now he's my boss's boss. But either way, this quote has been written in books. It's been used on stage. It is now the de facto definition of DevOps for Microsoft. And the most important word in this definition is value. Because if you're not delivering value, what are you doing and why are you doing it? And as we've learned throughout this journey, we've learned how we can not only deliver value, but how we can have confidence in that value. Now can we have confidence in what we're doing after we're delivering that, everything that happens after we've run our pipeline. So it starts with planning, as we've learned, developing, delivering, but now we're at the operation part. We're at the stage 4 of this DevOps definition. And another fun fact about this definition that not many people know, unless you've heard it from Donovan himself or a member of our team, Donovan actually spent 30 days working on this definition, 30 full days, so that he could make sure that him and anyone who quotes it could stand behind every single word. So we really want to make sure that we can remember the importance of that continuous delivery of value and including the operational part of that definition. Higher performance DevOps companies, those companies that have embraced DevOps, achieve developer velocity 10 times over. In fact, it's even more than that. They're able to have 208 more frequent deployments, 106 faster commits to deploy. We're able to have a faster time to market, which directly correlates to increased revenue. You're able to have a 7-time lower change failure rate and over 2,600 times faster incident recovery. And we'll learn how we can handle incident recovery today in this module. Now, you might have seen this comparison or this analogy before, but pre-DevOps or pre-2020, we actually had some incentives that were not exactly fair. Dev and operations were incentivized at one point in time to work against each other. There's this wall of confusion here because developers, it's in our nature to want to be agile. We want to have more change. We want to have our next sprint. We want to continue to iterate. And we just want to keep moving forward because we love developing and we love building. But operations, which I also know a little bit about because aside from being a developer now, I spent 10 years on the ops side. And I can empathize with that because operations actually just wants to keep the lights on. We just want to make sure our servers are up, which actually means as little change as possible, right? So now developers want to move quickly. Operations want to not move at all. It also creates this wall of confusion because we don't understand where the other person is coming from. And it kind of has this catastrophe. By actually using value as the focus, as the definition of DevOps reminds us, now developers and operations can actually work together towards a shared common goal, where both sides want to deliver value. We can now have empathy, we can now have understanding, and now we can work on actually that operation part of the DevOps process. So again, we've already seen this a few slides ago. We have our planning, develop, delivering. Now we're in the operation part because we have that shared common goal of value. So let's start with how we can have responsible incident response now that we're all on the same Tailwind Traders team. Disaster strikes. The website is down. Email notifications went out. Of course, email is so reliable. Everyone reads every email. But actually time goes by and the website's still down. We still have a problem. So incident notifications are not broadly distributed. A lot of times that's what people think. Even I've worked on teams where you get a P1 alert or a P2 alert or Sev1 or Sev2, whatever you want to call it, and we just email the entire engineering team. But it comes across as though it's only informational, we're only doing heartbeat or logging, and that's not actually true incident response. Instead, what incident response is they're specifically directed. Which teams or which engineer actually needs to be notified about this alert? What action do you want this engineer to take? And is this in need of human intervention? Or, as we'll come to learn, is this something that we can help tie automation in? So when we're working through establishing a basic designated responsible individual rotation, or a shift, this is pretty much just a fancy term for creating a incident response shift, we want to create a DRI, disaster recovery incidents, schedule using shifts, which is an app in Microsoft Teams, and we'll learn how we can do that. We're going to learn how we can create a logic app, which is really, really simple to actually connect over to that Shifts team app in Microsoft Teams. And that way we can notify the correct disaster recovery individual or responsible individual. And then we're going to learn how we can update the alert action target in the logic app itself. So this first demo, we're going to go through creating a basic DRI notification. All right, so we're going to start in Microsoft Teams. I have a team instance set up, and I've already installed something called the Shift app. When we click on Shift, you can see that we've already started to scaffold out the week for our team's shifts for incident response. We can take a look at the first shift here. We have it, when we go into Edit, you'll notice that we have it set for 24 hours. We've assigned the responsible individual, Stephen in this case, and we provided a date and time range for his shift to begin. We could add other things like notes or labels. We can add things like breaks, but we're going to keep it simple. Now, once we have our week or whatever time period we need defined, we can simply select the Copy Schedule button, and we can choose the date range we want to copy from and the date we want to copy our selection to. This will include all notes, activities, time off, open shifts, and even groups. Now, in this example, we're able to create the next 2 weeks for our shifts with only having to manually create that first week range. Now that I've done that, I'm still able to make any adjustments or tweak as needed before this is locked in. Once I've designed the shifts schedule exactly as desired, then I can share with my team, and that sharing action will actually lock in the schedule completely. When I opt to share with the team, as you'll notice, we'll just look here and make sure everything looks good. We have somebody assigned on every day. We're going to go ahead and click on Share with Team. And once I do that, I can decide what details I want to share or lock in. I can go by date range. I can share just one of the weeks we've created. I can share both of them. I can choose to share notifications with the entire team or only those that may be affected by this change. For example, if 2 people swapped shifts. Once it's shared, now we can say that the schedule is officially locked in and we can begin leveraging it for our other automation. Here we have our Tailwind Traders website, and if we click on our second tab here, this will bring us into our Azure portal, and we can dive into our resource group for this app service. We'll create a Logic app. So we're going to go to Add, and we'll search for Logic. There we go, Logic app. We'll click that. And Logic apps offer actually a super simple way to create a workflow that's going to connect with a lot of different services within Azure as well as other integrations. We're going to start with some basic information, our subscription, our resource group, and of course, a name for our Logic app. We'll call it Alerter. After we click Create, we're just going to be prompted to review all the basic information we've entered. Everything looks good, so we'll hit Create again. This is going to take just a few seconds to build. While it's building, we can actually see the deployment is underway. It'll give us deployment details, and just like that, it is already built. When we click the notification that it's completed, we're actually very nicely handed over to our Logic app designer. There's a little video introducing Azure Logic apps. It's going to walk us through, and there's even some common trigger templates that are provided. We'll select the one for HTTP requests because that's how Azure Monitor is going to interact with our Logic app. And one of the things that's interesting is Azure Monitor actually has a specified common alert schema that we can use. We can find that right in the docs for Azure Monitor. We'll just copy that, and then we can paste that schema from the docs over into our Logic app. We'll just add that to the request body. Great. Now, once we get that copy and pasted, we can actually start to build our action out. We're going to add a second step, and this step, we're going to have to pull and figure out who's actually on call. So we're going to search for the connector that's going to connect over to the Shifts app for Microsoft Teams. Here it is. We'll select that. We can see we have a number of actions we could select. We're going to find the one that's going to list all shifts. We can see list all open shifts, offer shifts. There we go. List all shifts. We'll go ahead and select that. Now we have to sign into our Teams account. This is going to persist our Teams credentials and bind them to this connector for our Logic app. Once it authenticates, we can then select which team we want to list all shifts for. So you can see right there under team, in this instance, we're going to want to choose the designated responsible team. And then we're going to add any parameters that we need for our particular time window. Now, I don't actually care about all shifts. I care about all of them during a particular time block. Since we have 24-hour shifts, the way this action works is it's only going to return the shifts that are fully encompassed in whichever defined time window we have. So we're going to go to our expression window and we're going to type add days. There we go. Days, there we go. And then in our parentheses, we're going to start taking the time now. We're going to subtract from 1. We're going to go back 1 day. And then we're also going to go for the end time and we're going to go forward 1 day. So this is going to give us that full 24-hour window for our shift polling. We'll do add days again. We'll do the time now again. And this time we'll do +1. Now, since we have a 24-hour shift, with this expression, we should only get just one shift result returned because only one 24-hour time window is going to be in that time frame. Unless, of course, my incident is happening right at midnight, of course, in UTC time or something like that, in which case we'll probably get 2 shifts returned. And in that instance, honestly, it's okay if I ping 2 people, so I make sure that the incident is still resolved. Okay, once we have our list shift step defined, we now need to add another action to actually iterate over that previous list result, because the list result is actually going to give us an array, even if there's only one result. We're going to look for a simple for each loop, there we go, and we're going to select the array list output from the previous step. That's what we want to iterate over. From that for each loop, we're going to look and we're going to add another action to get the details about that shift we listed, because we need to know who's actually assigned to that shift. So we'll select get a shift, select our designated responsible team again, and then for shift ID, we're going to go over to our dynamic content option list and we're going to search for the shift ID, which is going to give us the unique ID of that shift. Great. Now we're going to add another action. And this time we're going to search for Microsoft Teams, that connector itself, not the Shift app connector, just Teams. This is going to allow us to begin to craft our message to that ID we pulled in our previous step. Under actions, we're going to choose the get@mention token for a user so we can ping that user accordingly. We're going to have to sign into Teams again because this is actually creating an authentication between Logic Apps and Teams as opposed to Logic Apps and the Shift connector. It's just a different way that it authenticates. Now under user, we're going to again search for a dynamic content, and we're going to have to see which shift was assigned to the shift ID that we identified in the previous step. So if we scroll down, we'll find shift assigned to user ID. Very simple. And that's going to let us actually look up that mention token for the Teams user we want. Now we're going to be able to actually send the message to the person on call. We'll add an action again. We're going to click on Teams, and now we're going to find the option to post a message. This option is going to actually allow us to post a message as something called the flow bot. Flow is the previous name for Power Automate, and Power Automate, Power Apps, Logic Apps, all of those actually share a number of connections together. They have things in common. Now, 3 of these connections we've used right in this demo. We're going to select the necessary team again, designated responsible. Under channel, this time we're going to select front end incidents because this is an incident that's going to happen on our front end. That's how we're going to use this alert. And under parameters, we're going to choose to start defining the parameters we want. Now this message is going to be sent as HTML, so we're going to paste in a sample message here with using some dynamic content. You can see that we're using our @mention along with alert rule, severity. We'll find the date and time of the alert, the link for where a responder can go get more information, and other general details. We'll hit save, and if we scroll up, you'll see we actually have an HTTP post URL. We'll grab that to our clipboard, and we can use that to send some test data to make sure this Logic app functions exactly as we would expect. Great, so now we're going to head on over to Microsoft Teams, and just like that, you can see we actually have a test alert coming through. This is excellent. This is exactly what we want. We can click the alert. We can see we got a mention for Steven. We can see the data of our alert. We can see that it's a Sev2 issue. We can see the alert time, the number of errors, and the portal link. So now that we know this works, let's do one last thing and wire this app up into our alerting infrastructure. We're going to head on over to Azure and then to our app insights for Tailwind Traders. We're going to scroll down on the left-hand side to alerts. We'll click on the Manage Alerts rule right up here at the top. There we go. And you can see that we currently have 2 alert rules in place, one of which is conveniently named Bad Stuff is Happening. Currently, this rule defaults to sending a lame email. Now, the email rule isn't exactly working, probably because no one reads their email. So we're going to select an action group, and we're actually going to choose to create a new action group. We're going to have this alert go to our new Logic app that we just created. We'll again have to give some basic information, a short name for a group. We're going to select the resource group. We're going to name our action. We're going to choose an action type. Now, in our case, our action type is going to end up being Logic app. So you can see right now we're entering a short name. We're making sure that we're in the right resource group. This is very important. And then we're going to name our action name. We'll just call it Logic app. And we'll make sure that we say it's alerts. Under action type, this is where we find, yep, there we go, Logic app, perfect. And now under that, we're going to make sure that the Logic app we're pointing it to, that we're also in the right resource group. And then it's going to automatically be able to go find that Logic app that we just created. It finds it right away. We'll leave the option to enable the common alert schema as is. We'll hit OK. And now we'll have to hit OK a second time for that action group. Once we do, action groups can be used by more than one alert rule, which means we can actually set this up in a generic fashion and we can use it any way we desire. We'll leave the email alert rule as is, it's not hurting anything, and we honestly want to make sure that we're comfortable with how this new alert rule and the Logic app behaves. Wow, okay, so that was a lot, but it was super simple to do, right? We could actually create our shift, we could handle our notifications, we can ping the specific individual who's responsible and who's on call, and we could do all of that by using automation. Now, if certain parts of that were lost or you wanted to figure out where you could go get the common alert schema, as I mentioned in the demo, all of that is available on Docs, where you can actually see tutorials, samples. Docs is really kind of the de facto place to go when you want to learn anything. But if you want to check out aka.ms docs/alert schema, it'll take you right to that resource that we used for our logic app. Now, we mentioned earlier that there's no magic people or machines, right? There's no snapping our fingers or just clicking a magic button. We actually have to identify the problem and really kind of work through it hands-on. So in this instance, a previous engineer recently left for a new role. Several components of the application infrastructure had access control tied to that person's account. And if you've ever been in this scenario, when the person leaves and unfortunately their user role or their account was the one that actually held the keys to the kingdom, now you're going to start having issues. Things won't be able to authenticate. You're going to start having a bunch of problems. So as you can probably expect, this led to cascading failures across our entire Tailwind Traders environment. How do we solve for that? Well, first, we can actually use something called managed identity or Azure managed identity in Azure. This is where we can actually have identity authentication over keys or a user account. By creating managed identities for specific services, specific applications, and then using service principals attached to that identity, we have now removed the service principal from the user or removed the user as a potential bottleneck. We also can tie in managed identity to other things like Azure Key Vault, where we can actually store other secret information, including database connection strings, certificates, and other parts of our infrastructure and security management. Identity in Azure is very important and actually incredibly simple to set up, as we'll learn. So in this next walkthrough, let's go ahead and set up an assigned managed identity together that we'll later learn in our last demo. Now, setting up a managed identity in the portal is actually pretty straightforward. We simply go on over to our resource. In this case, we've headed on over to our app service. We're going to scroll down to identity on the left-hand side. When we click that, we can see that we have two options. We actually have system assigned or user assigned. We can also toggle this status to on or off. We can enable system identity. We're going to go ahead and toggle it to on. We will then be asked to confirm if we want to enable system assigned managed identity, which we do, so we're going to go ahead and click yes. Now from there, Azure is going to go out and do the rest of the heavy lifting. It's going to go out and create the identity, it's going to give it an object ID, and then we can go and assign role permissions. We can see the identity has already been created, and now we see the button to assign permissions. We can also use managed identities for future things like Azure Key Vault. All right, again, that's one of my favorite demos because it's so quick, it's so easy, it's so fast. And if you want to learn more about identities, again, you can head on over to docs, aka.ms/docs/identities. We'll go through application registration, setting up service principal objects with your identity, how to handle permissions, how to really build on top of what we just learned with creating the identity itself. Now, let's kind of wrap up with how we can choose tooling over tasks. This is where we start to automate things that maybe people were manually doing or what we like to call heroically doing. They're doing more work than is necessary because it's something that we can, again, build in automation. So another quote from Jeffrey Snoper back in 2010, he says, "I can't see the value of automation," or "you can't see the value of automation." At some point, it's just simply an IQ test. It's just a matter of if you're not getting it, let's set it up. And the first time it goes off, the first time it works, it's like the light bulb goes off of, oh my gosh, this is so valuable. This has just saved me 10 minutes of having to log into the portal, click on my web app, go ahead and restart. Instead, I could automate that with something called chat ops, and we'll talk about that. So as we've built up, we're going to learn how we can reduce manual intervention now that we're in production. We're going to move any kind of manual repetitive tasks over to automation. We're going to start with one. We're going to start with a demo. We're going to minimize the long-term user principal role assignments. So we're going to take that managed identity that we just created, and we've already given it only the permissions that it needs, and we're going to actually use that in our next automation task. We're also going to make sure that it has a central secret store that we're relying on so that we don't have secrets flying around or up in the open or tied to any particular person. So this next demo is we're going to dive right in. We're going to use a logic app, Microsoft Teams, and we're going to create flexible automation to restart our Tailwind Traders web application. All right, here we are. We're back in the Azure portal, and a common task we might have to do is restart our web application. Let's look at how we can validate that the automation we're going to create is going to be able to handle our restart task. We can head on over to our application logs, and we can begin to search for the last time our application was restarted. Now I can see that I have 2 timestamps for application starts. Great. Now I can pop back over to the app service dashboard and click restart. I'll use the logs to see what kind of message posts when the app is restarted. Now we're going to wait just a few seconds and then we'll refresh our logs to see what that restart looks like. Remember, we're just using this app as an example to see what kind of tasks we can automate. Rather than giving team members access to our application so they can go do simple things like restart the web application, we can actually leverage automation that's built right into Azure. Okay, now it's refreshing, and for some reason we get 2 application started alerts. Again, that's okay, that happens from the web portal, but at the end of the day, we now know what we're looking for. So let's go back and actually build a logic app that's going to handle this restart functionality. We're going to go back to our dashboard, we're going to click add, we're going to search for logic app again, and we'll click create. We're going to enter all of our basic information. We know to make sure that we want to select a region, we're going to give it a name, we're going to fill in any other information, resource group, subscription, all that looks good. We're going to click on review and create, we'll review it, and then we'll simply hit create. We've done this before, luckily, right? So this is easy. We also know, since we've done this before, that this goes quite quickly. Just like that, it's already succeeded. We're going to go over to that resource. Now, last time we actually used a predefined template, right? We used something to do when an HTTP request is received. This time, we're going to actually use a blank logic app. You can see we scrolled all the way down, and now we're going to search, or we're going to get started with Microsoft Teams as our trigger. When a new channel message is added, we're going to have it do a bunch of tasks. We're going to add some conditions, some if-else statements. We're going to start off with adding the team, designated responsible in this case. We're going to select the channel. We're going to choose front-end incidents again. And now we're going to set how often we want this logic app to poll our Teams channel for information. We're going to set it quite low at actually about 5 seconds. If this were production, we could set it a little bit higher, but for the sake of this demo, we're just going to set it very simple. Now we're going to add another action, and this time we're going to set it to initialize a variable. And the reason why we're handling variables now here with step 2 at the top level is so that we can use them further on down in our action. We're going to use nested conditions, as I mentioned, and when you start dealing with nested conditions and if-else statements, if you haven't actually initialized a variable you plan to use, then it gets quite complicated. So we're going to name our variable reply. And for type, we can choose different types we want this variable to be. We're going to set it to be a string because we actually want it to hold our string or our reply for our text. Great. Now we're going to add another action, and this time it's going to be a control action. We're going to set up a condition, a control condition. This is going to check a few things. First, it's going to check, is this chat message that it received from the trigger for our automation, does this contain a keyword? Is it meant for our automation? We're going to find the message body content option under dynamic content because we want to take a look at the message body, and see if there's a keyword. For example, tailbot in this case is present. We're going to select starts with as opposed to contains, and we're going to enter tailbot as the keyword. Now we're also just going to rename this so that when we're visually looking through our logic app, we know what step this is, especially since we're going to have a lot of steps. You'll notice just by looking at this that this is really just a colorful, glamorous if-else statement. If it does start with tailbot, we'll do something. If it doesn't, we'll do nothing. Okay. Now we're going to go add an action for if true. We know that we're going to need to respond. And I know I'm going to need to get an @mention token for the user so our action can actually respond to whomever sent the message. We're going to scroll down and we're going to find the option for message from user ID. And we're searching for this because this is going to give us our ID that we can then use. Remember, we kind of used this earlier in the last action or logic app we created. Now, after we have our ID, we're then going to check for the contents of the message again with another condition. We're going to look at the message content again to see now if it contains a string of text. So we'll go ahead and add in another condition here. Again, that's just under control. You can see we have a few different control conditions. We'll add this action under true, because if it contains this new string of text, then we're going to have it do something. So under condition value, we're going to say if the message body, not that message body, scroll all the way down. And don't forget, you can also search in dynamic content, but we're going to search for message body content. And then under here is we're going to say that we want to make sure that it contains the string restart the web front end. So we'll change the condition to, rather than is equal to, we're going to change it to contains. Perfect. Now, if that's true, we want to actually go and restart the web front end. Logic Apps has built-in connectors for working directly with app service. So we can actually go right up here and we can search for app service. Lucky us. Now, the first action, surprisingly enough, once we click on app service and scroll down, first action right there is restart web app, and that's exactly what we want. We're going to select that, and you'll notice that we're going to have to sign in to connect. Now, this time we don't want to use a user ID. Instead, we're going to use a service principal, right? We learned about service principals to connect. This way, we don't have to have any particular user's ID associated to how this action behaves, right? We minimize the potential bottlenecks that we have there. So we're going to need to specify the client ID. This is kind of like the username. We're going to have to specify the client secret, which is kind of like the password, and then which Active Directory to look in. Now, service principals can be used across multiple tenants or across multiple subscriptions. So Azure actually calls this tenants. So we're going to make sure that we specify the right tenant ID, and that's going to set up the connection over to app service. Once we have the connection created, you'll notice from that point, we'll be able to actually start selecting the app service itself. Now we can fill in the details for our web app, which subscription our app is in, which resource group, and the app name itself. Now remember, our service principal that we're using only has rights into one subscription. We can add the action again, and then we'll need to set up a reply since our restart trigger is configured, okay? Now we're gonna set a variable again for this condition, and we're gonna use the variable we created in the beginning, okay? That was that reply variable. So we're gonna go search for variables. There we go. And this time we're going to use the option to set that variable. We can choose the name, and you'll notice reply pops right up. Perfect. Now we're going to have to enter a variable value. And this is where we're going to start tying things together. We use the @mention token, and then we use a set of predefined text. In this case, I have restarted the web front end as you requested. That's what our bot's going to say. Now, if it receives a message that it doesn't understand, that doesn't say restart the web app, we're going to set an if false condition for set variable. This time the reply is going to contain or have a different type of reply. We're going to say I'm sorry @token, I don't know how to, and then we're going to use a regex expression to actually replace the text and grab that part of whatever the user requested that the bot simply doesn't understand. Perfect. Now in either scenario, we're going to add another action. This is because we want to actually send the reply in any scenario, whether it's true or false. We're going to find Teams again, and we're going to choose to post a message. We're going to fill in details before. Again, we've done this several times now. We're going to fill in Teams, we'll fill in our channel, we'll fill in our message ID. We'll just choose the post message, and here you can see Teams, we'll choose designated responsible, we'll fill in the channel, and for message, we can have it be that variable that we've now set. And the beautiful thing is we only have to do this action once because we've kind of set up our if-else statements with variables that are being captured. So all we have to do is reference the message or the dynamic content accordingly, and we're just going to search for that reply variable, and it's going to contain whether it's true or whether it's false. The previous condition will go ahead and act that. There we go. Now we could also add in a subject of the message if we wanted, but we're just going to leave it as is. Everything should be functional, so let's go ahead and save it. Perfect. And then we're going to flip back over to Teams and actually test this out. Okay, now we're in Teams again, and we see our previous alert there. We're going to ask Tailbot to restart our web application. So I'll say Tailbot, could you restart the web front end? Remember, that was our text that we used for our logic app we just created. Okay, now we're gonna wait 5 seconds roughly, which is the time increment that we set, and we can see if this logic app begins to really start enabling this chat ops experience for our team. We're now going to be able to automate simple tasks such as restarting. This is going to free up time and resources on our team so we don't have to manually or heroically go out and do things that really can be automated. And also, since this is happening in our front-end incidents channel, other members of our team can also see that the app is being restarted, as opposed to someone directly having to go and tell someone or text somebody, hey, guess what? I restarted the web app. All right, there we go. Now we can see that the web app was restarted as requested, or at least that's what our logic app bot says. As much as I'd like to trust Tailbot, let's actually go verify that it was actually restarted. We'll head back over to our browser, and we're going to take a look at those logs again. We want to make sure that the application has started again. So we're going to refresh our logs and see what we get. Getting our data, hang in there. And cool, just like that, we can see that there is a most recent timestamp so that we know now confidently that our application was restarted. Now let's test what happens when Tailbot gets a message that it doesn't understand. Remember, this is that false condition that we defined. We're gonna ask Tailbot to go get us some coffee. Tailbot, could you get me some coffee? Which is perfect because I could really use coffee. And Tailbot should reply, and just did, with the message that we told it to use. I'm sorry, it used the app message token to tag the user sending the message, and it says, I don't know how to, quote unquote, get me some coffee. The quotes was where we were able to use that regex expression to actually grab the statement or whatever the request was that Tailbot didn't understand, and it could put that right into the message. Now, of course, we could create a service account for Tailbot to use, which we probably would in a real production scenario. Since we didn't, you'll notice that these replies from Tailbot are actually using the same name of the user, because it's the same name of the user that created the logic app. So take that with a grain of salt. In production, we probably would want to create a specific service account for our app, but now we have confidence that our application or our logic app and our automation actually is working as designed and intended. All right, let's do a quick review because we've learned so much and it's been so much fun. First, we've learned about how we can handle responsible incident response. We've learned about shifts, we've learned about teams. Again, remember, if everyone's responsible, no one actually is. It's kind of like human behavior. You send an email out to everyone, and it's kind of natural for that whoever reads the email to think, oh, this went out to the entire team, someone else will handle it. It's not going to be my problem. As we've learned, by using DRI, using shifts, and using teams, now it pings a specific person, and that person knows it is absolutely their problem. We know now that there is no magic people or machines. We have to be responsible for secrets, for passwords, for authentication. So we learned how we could actually tie in managed identity and remove the user as a potential bottleneck and remove the potential for catastrophic failure. We also learned how we could let machines do the repetitive tasks, right? We learned how we could do chat ops, how we could tell the bot that we built in Teams to restart our web app, as opposed to having to take 5 to 10 minutes to log in, to click on the right service, to restart, or what happens if we shouldn't even have those permissions in the first place. This way we can make sure we're doing things right and we're using the tools necessary to solve the problems that already exist. Now, for all of the resources for our session, you can check out Microsoft Learn. Again, this is a really great place to get hands-on material. You can actually even check out training for the AZ400 certification. You can head on over to aka.ms, getting-started-DevOps, and then you can even get certified. There's actually designing and implementing Microsoft Solutions certifications. If you want to learn more about that, that's at aka.ms/AZ400-cert. And again, we've just touched on this, but Microsoft Learn, or learn.microsoft.com, is one of the best ways to get hands-on training to go through different modules or learning paths where you actually can walk through everything that we've talked about today. We're constantly adding new modules, new learning paths, and best of all, it's entirely free. Wow, what an amazing journey. This concludes our Microsoft Azure Virtual Training Day DevOps with GitHub event. First, let's recap on all the amazing content you've seen. Tailwind Traders really has been on quite the journey. They've learned what exactly DevOps is and how easy it is to get started with it. They learned how they can easily and efficiently manage the flow of work, how they can successfully deliver change and enable automation for deployments. And then they continued to build on top of those amazing skills that they gained, and they were able to also have confidence in the deployment process, in the security of what they built, both infrastructure and microservice-wise. Finally, they learned how they could refine and improve their DRI on-call process, how they could improve incident response practices, and move many regular tasks like restarting a web app over into logic apps and use chat ops and use managed identities. Thank you so much for attending, for hanging out with us, for being part of the Tailwind Traders team today. We really hope that you enjoyed these sessions. Remember, there are many ways to continue your learning journey. One of the best ways is Microsoft Learn, where we offer self-paced learning options completely for free. Be sure to check the calendar for more Microsoft Virtual Training Day events, and thank you very much for hanging out with us today.